If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it is, it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Yarkovsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. OSIRIS-APEX will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. OSIRIS-APEX has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare. Let's do some quick math. A commercial airplane can fly at 575 miles per hour. Our rockets fly into space at 26,400 miles per hour. But this asteroid breaks all records and zooms at 33,000 miles per hour. That's 43 times faster than the speed of sound. At that speed, you could cross the Atlantic Ocean in just 5 minutes. The worst part is that this thing could crash into the Earth. This is Asteroid 2021 RX-9. It's 120 feet wide. That makes it 1/3 the size of a football field. It was only recently discovered, and scientists were able to calculate its orbit. It's not round like most planets, it's an ellipse, like if you squeezed a donut a little bit. RX-9 begins its journey toward the center of the solar system, about 273 million miles from the Sun. It crosses the asteroid belt, then the orbit of Mars, and the orbit of Earth. It makes a circle around our star and then shoots back like a slingshot. The asteroid will move away from the Sun until the star's gravity forces it to begin its return journey. RX-9 makes one such round trip in 2.5 Earth years. Although the orbit of this asteroid intersects with that of our planet, it's not dangerous to us. The closest it'll get to Earth is 7.5 Earth-Moon distances. But there are many other asteroids in space. RX-9 could collide with them and change its trajectory. And that could put it on the list of potentially hazardous asteroids. And this thing is asteroid 2021 NY1, and it's already on the list. It's as big as 2 Statues of Liberty, and it's moving through space at 6 miles per second. So this asteroid could take you to the Moon in just 11 hours. Its orbit is also elliptical. Its far point lies somewhere between the asteroid belt and Jupiter, at 3.9 Earth-Sun distances. The closest point of its orbit to the Sun is right near the Earth's orbit. Asteroid NY1 has passed Earth at only 4 Earth-Moon distances. It'll make a circle around the Sun and head back to its starting position. The asteroid makes a complete orbit in almost 4 Earth years. The record for the closest approach to Earth belongs to asteroid 2020 VT4. It's a rock the size of a bus, and it flew at an altitude of 230 miles above Earth. For comparison, the International Space Station orbits our planet at 250 miles. So it literally flew over our heads in the region of the South Pacific Ocean. And we didn't even know this asteroid existed. It flew over the Earth at daytime, and we couldn't see it because of the sun's light. Scientists only learned about this asteroid 15 hours later. If it had fallen on Earth, well, let's say we could have had a very bad day. Although this asteroid was small, it was moving extremely fast. That gave it a tremendous amount of energy. But we have a shield that protects us from space rocks, our atmosphere. It's full of air particles. So when an asteroid enters our atmosphere, it begins to break against these particles because of friction. This heats up the asteroid so much that it begins to burn. This is the reason why the bottoms of our space shuttles were protected with black tiles. They could withstand temperatures up to 2,300 degrees Fahrenheit. So, if an asteroid is small, it could burn up completely in the atmosphere and turn to dust. If you look at it from Earth, it would look like a falling star. Scientists believe that any asteroid under 80 feet in diameter will burn up completely in the atmosphere and cause no harm. But an asteroid larger than 1.5 miles can do a lot of damage. And we know of such an asteroid that regularly passes by our planet. 4179 Toutatis. It's 3 1/3 miles wide, so it's bigger than Central Park in New York. And if you put this rock on scales, well, it'll show 5 + 11 zeros tons. That's heavy. The most frightening thing is that this asteroid moves in a chaotic orbit because it's constantly being affected by Earth and Jupiter. It's like the planets are playing ping pong with this giant rock. It also causes the asteroid to rotate like crazy. If you were on the surface of Toutatis, you would see that our Sun constantly rises and sets in completely different places. Because of this chaos, scientists can only predict the movement of this asteroid 50 years in advance. In 2004, it came within 4 Earth-Moon distances from our planet. Fortunately, there's a chance that one day it'll leave our solar system. Jupiter or Earth will launch it into distant space like a slingshot. But if it did fall to Earth, it would cause gigantic tsunamis and earthquakes all over the planet. Then the existence of our civilization would be in question. A similar catastrophe happened about 66 million years ago. At that time, I wasn't around then, but I heard about it. An asteroid the size of Manhattan flew toward Earth. The sun heated its surface and vaporized the material from it. The dust and steam turned into a giant tail that glowed brightly in the night sky. The night before it fell, it was the brightest object in the sky, perhaps even brighter than the moon. The moment this asteroid entered Earth's atmosphere, it caused a popping noise so powerful that you could hear it on the other side of our planet. It began to burn. Small fragments began to fall from the main body of the meteorite. Some of them burned up completely in the atmosphere, but others fell to the surface. The moment of impact, the mass and speed of the meteorite gave it colossal energy of about 100 teratons in TNT equivalent. That's a big boom. All this energy turned into heat. It was literally a wall of fire that spread around the impact site and burned everything in its path. The blast wave from the touchdown circled our planet several times. It caused a tsunami with waves higher than the Empire State Building and earthquakes so strong that the ground literally cracked. After this incident, about 95% of all life on Earth ceased to exist. The meteor left behind a crater as wide as 66 Golden Gate bridges, and it was so deep you could stick 2 Mount Everests in there. And there are still many objects in the asteroid belt behind Mars that pose a threat to Earth, like Ceres. It's not just any asteroid, it's a dwarf planet. Although it has a mass of only 1% of that of the Moon and is as wide as Texas, yeehaw, it gravitationally affects the orbits of Earth and Mars. A collision with an asteroid of that size would simply destroy the Earth, tearing it to pieces. So, humanity must learn how to avoid colliding with dangerous asteroids. Here, we have 2 options: destroy the asteroid or make it change its trajectory and fly past Earth. Destroying a huge rock that weighs as much as an entire city is difficult, so we stick with the second option. We can send a spaceship with explosive there and then do a little boom. Only we don't have to drill a hole to plant this present inside the asteroid. The boom has to be right above the surface and pointing upwards. Then, according to the law of physics, the asteroid will shift down a little bit. Even if the asteroid moves only a few feet, on a cosmic scale, this would dramatically change its trajectory. Another option is a gravity tractor. The principle is simple. Any object that has mass also has gravity, even you. Yes, you have your own gravitational force. So our plan is to send an unmanned spacecraft to the space rock. It would just have to hover over the surface of the asteroid. Then the space rock will attract the spacecraft, but the craft's engines will resist. As a result, the asteroid itself will start pulling toward the spacecraft. Voila! Earth is saved. We can also use solar power. All we have to do is build a giant space station out of thousands of magnifying lenses and send it to the sun. When we spot a dangerous asteroid, the station will focus the sun's rays on the surface of the asteroid. The ice from its surface will begin to evaporate and move upward. The reactive force will push the asteroid down. Or deliver a giant cloak of shiny material like foil to the asteroid. If you wrap the asteroid in such material, it'll reflect the sun's rays. Again, the rays are reflected one way and push the asteroid slightly the other way. This method can only work if we have a few years to spare before the asteroid arrives. Another strategy is to attach a solar sail to the asteroid. It would work like a parachute, only it won't be braking against the air, but against the sun's rays. And the simplest option? We could attach conventional rocket engines to the asteroid. Then we can not only change the trajectory of its flight, but also control it. And if a big asteroid appears on the horizon, we can use the controlled space rock as a giant ram.
In 2007, astronomers spotted a massive 54-ton asteroid roaming space relatively close to our planet. But later they lost track of it. That's why the space rock was declared a lost asteroid. Almost 2 decades have passed since then. And in November 2023, a report claimed that the lost asteroid, aka 2007 FT3, might hit Earth in 2024. Such news sounds ominous. But how true is it? Well, NASA disagrees. The U.S. Space Agency has refuted the worrying claims. This statement was issued in response to the announcement that there was a 1 in 11.5 million chance of the asteroid striking our planet on the 5th of October, 2024. The space agency states that at any time in the next century, there are no known asteroids that could pose an impact threat to Earth. NASA and other space agencies are watching the skies nonstop, determined to find, track, and categorize asteroids and NEOs near Earth objects. Hundreds of millions of rocks orbit the sun within the asteroid belt between Mars and Jupiter. But only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects. Inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they might turn into a real threat to the world should a direct collision occur. Luckily, the larger an asteroid is, the easier it is for our planetary defense experts to find it. The orbits of the largest space rocks around the sun are normally well known and determined for years and even decades. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object reaching 1,610 feet across. It might smash into our planet in 159 years. According to experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If it hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. But even though Bennu's chances of colliding with Earth are quite low at the moment, the space rock has still been categorized as a potentially hazardous asteroid. All because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Asteroid 99942, 942 Apophis, also known under the dramatic name of the God of Chaos, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was still a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years.
Imagine flying in a spacecraft in a cloud of asteroids at high speed. You dodge one more, and then hit the gas pedal to the floor and crash into an asteroid at full speed on purpose. This is exactly what NASA is going to do in the near future. The entire mission will begin at Vandenberg Air Force Base in California on November 24th. Let's follow it step by step. So, the Falcon 9 booster rocket is already on the launch pad. It's as tall as a 22-story building, or 11 giraffes, and it can get about 8 tons of cargo into orbit. So you could send a big elephant into space, and a supply of food for it. Countdown, 3, 2, 1, ignition! Smoke clouds everywhere, and the rocket begins to gain altitude. 9 engines are working at full power to accelerate the rocket. At its peak, it reaches speeds 10 times faster than the speed of sound. And then, the rocket engines shut down, and the rocket's first stage undocks to return to Earth. A couple of seconds later, the second stage receives the ignition command. It turns on its one engine and climbs even higher to orbit. The cargo capsule then opens and releases the DART spacecraft. DART stands for Double Asteroid Redirection Test. Once released, the spaceship deploys 2 large solar panels. It'll convert solar energy into electrical energy to power a revolutionary ion engine. Conventional engines create thrust by burning tons of fuel and ejecting it outward. The rocket itself is essentially pushing off the emitted gases. The ion engine will not burn fuel. It'll use a strong electric field to accelerate the ionized gas. Like conventional rockets, it'll eject this gas and create thrust by repelling it. And though the ion engine produces less thrust, it can accelerate the spacecraft to higher speeds. So regular rocket engines have an excellent performance on the road. They push the pedal to the metal, burning a bunch of fuel, while the ion engine slowly accelerates. But when a conventional rocket needs to make a refueling stop, the ion spacecraft will whiz past the regular one at insane speeds. So the DART spacecraft begins its year-long journey. By comparison, a flight to Mars would take about 7 months. Fast forward 1 year ahead, and we've arrived. This is the asteroid Didymos. The far point of its orbit is 2 astronomical units from our star. That's 2 Earth-Sun distances. At this point, the Sun begins to pull the asteroid back, and then it approaches the closest point to the star, 1 Earth-Sun distance. That is, its orbit lies very close to the orbit of our planet. Didymos made its closest approach to Earth at a distance of about 4.8 million miles. That's 20 times farther than the Moon's orbit. It takes 770 days to complete one such revolution around the Sun. So, Didymos is not considered a hazardous asteroid, but in the future, it'll approach the Earth even closer. And the consequences of a collision with it could be catastrophic, given its size. It's bigger than 2 Empire State Buildings, and it rotates at a rate of 1 revolution in 2 hours and 15 minutes. So it has a tremendous amount of energy. Plus, it has an asteroid companion. It's a small pebble 520 feet wide. It's like 12 school buses or 10 train cars. Its orbital period, that is, the time it takes the pebble to make a complete circle around the asteroid, is about 11.9 hours. NASA believes that asteroids up to 80 feet wide are likely to burn up completely in our atmosphere due to friction with the air, so they're not hazardous. Asteroids between 80 feet and half a mile in size will not burn completely and could cause severe damage. And asteroids over half a mile have the potential to wipe out large cities or even entire states. In that sense, we can consider Didymos potentially hazardous. So we're going to test one way of defending against asteroids on it: kinetic impact. That's why we sent DART here. So our spacecraft is going to hit an asteroid, only not its main body, but its little companion. DART is already moving toward it at about 4 miles per second. At that speed, a trip from New York to Washington, D.C. would take less than a minute, and a trip across the United States from coast to coast would take about 10 minutes. DART is getting close. 3 seconds to impact. 2, 1, BAM! The spacecraft crashes into the asteroid at full speed. What are your predictions? Asteroid explodes and is blown to pieces? Or asteroid flies off the main body into space like a billiard ball? Well, scientists predict that this collision will reduce the speed of this small asteroid by a fraction of a percent, but it'll still be enough to reduce its orbital period by a few minutes. Then our telescopes on Earth will be able to study the effects of the collision in more detail. And to learn even more, we'll send another spacecraft to Didymos on another mission. This is Hera. It'll be launched in 2024 and is scheduled to arrive at Didymos around 2027. This spacecraft will carry a bunch of research equipment to assess the collision damage done by DART. When it arrives, Hera will take many pictures of the small asteroid, including a fresh impact crater. Hera will also be carrying 2 CubeSats. These are miniature space probes, smaller than a shoebox. It'll launch these mini satellites, and they will make an even closer approach to the asteroid. They will study this space rock for 3 to 6 months. At the end of the mission, one of them will attempt to land on the asteroid's surface to learn even more about its composition and internal structure. It's also possible Hera will carry a mini impactor. This thing will have to make another impact on the asteroid. Then scientists will be able to evaluate the difference in impacts with a large spacecraft and a small one, and understand how we can defend against asteroids in the future. In theory, we don't need to send a giant rocket to a dangerous asteroid to destroy it. A single strike might be enough to shift the trajectory of the asteroid slightly. On a cosmic scale, changing the trajectory, even by a fraction, would dramatically change the asteroid's finish point. But kinetic impact is not the only way to deal with hazardous asteroids. Check out the gravity tractor. For this technique, we need to send a spacecraft toward the asteroid too. Only it won't crash into it. It'll have to go into its orbit. Any asteroid has a force of attraction, and it'll pull the spacecraft toward it. But the spacecraft's engines will keep it at the same altitude, so the asteroid itself will start attracting to the spacecraft. This method is reliable enough, but it takes a long time. And it'll only work if we detect a potentially hazardous asteroid many years before it arrives at Earth. We should have enough time to send a spacecraft to the asteroid and then carry out an asteroid tractor technique. The other option is a laser. When an asteroid is found, we need to aim a powerful laser beam at it. It'll heat up a certain point on the asteroid, causing the material there to evaporate. This is where physics comes into play. The material on the asteroid evaporates upwards. It makes the asteroid itself move downward. Just like our rocket engines work, the burning fuel is ejected one way and the spacecraft moves the other. We can also use solar power instead of lasers. To do that, we need to build a big space station, which would be equipped with a lot of magnifying glasses. Have you ever tried to burn letters on a wooden surface with a magnifying glass? Well, we'd be doing the same thing, but with an asteroid. The space station will have to focus lots of the sun's rays into one point on the asteroid. Again, the material evaporates because of the high temperature, and this causes the asteroid to change its trajectory slightly so that it flies past our planet. How about foil? That's right, we can avoid a collision with an asteroid by using ordinary foil. We would have to wrap the asteroid in the same reflective material. Then the asteroid won't absorb the sun's rays, but will instead reflect them. This creates a little pressure on the surface of the asteroid. It's as if the sun's rays are pushing the asteroid, and it'll be able to change its trajectory. And not the most obvious but reliable option is conventional rocket engines. We can put several powerful engines on the asteroid. This would create thrust and change the trajectory of the asteroid. And if there are enough engines, we can even take control of the asteroid. So when a bigger space rock appears on the horizon, we'll turn on our engines and point the asteroid straight at it. Such a collision can completely destroy even a very large asteroid. And it would make for one epic light show.
Asteroids flying around is sometimes like a fierce game of dodgeball, where you never know when some of them can go in your direction. So we can just track the situation and hope for the best. To figure out the risk, scientists from different organizations have to study the positions and paths of the asteroids that come close to our planet, especially those that are at least 0.6 miles wide. And the good news is that none of these asteroids will probably hit us for at least the next 1,000 years. Phew! To give us an idea of their power, scientists did an experiment to simulate the impact of such a gigantic asteroid. The energy released from the collision would be a mind-blowing 100,000 megatons. That's like detonating 15,000 tons of dynamite. Also, if such a big asteroid hit us, Earth would cool down significantly because of all that debris that would go into the atmosphere and block sunlight. Plants wouldn't be able to get their fuel in this case, so we'd all be in trouble, both humans and animals. Thankfully, such mammoth asteroid impacts are quite rare. The larger an asteroid, the longer it takes it to collide with Earth. For example, it's estimated that asteroids with diameters of at least 0.6 miles strike our planet about once every 700,000 years. And if we're talking about even bigger ones that are 3 miles wide, well, those are predicted to come crashing down only once every 30 million years. Yay! But hold on. Don't get too relaxed just yet. Astronomers focus on really large asteroids because those are the ones that can kinda doom our planet if they hit us. Yep, you got it right. In a dinosaur kind of way. Even if one of them didn't erase us completely, the damage would still be enormous. So, there are still some asteroids wandering around that we need to keep an eye on to see how they might evolve over time. Scientists have a model of tracking them where they focus on the parts of an asteroid's path that come close to our planet to see if the space rock poses a risk to us. And it seems there might be one asteroid, 7482, 1994 PC1, 3,600 feet in diameter that might pose some danger. It's supposed to come closer to our planet in the next 1,000 years. And when I say risky, it means there's a 0.0151% chance of it coming within one Earth-Moon distance. It already passed by us in 2022, but we were lucky because it was far enough 1.2 million miles. I'd say we can relax when it comes to asteroid scenarios. For now. Asteroids slamming into Earth would be new for humankind, but not for the planet itself. As I said, there weren't many of those big ones, but they still had enormous consequences. The first one that comes to most people's minds is, of course, the Dinosaur asteroid as big as a mountain that struck our home planet around 66 million years ago, near Mexico's Yucatan Peninsula. It was chaotic. Global firestorms and tsunamis were all over the place. Dust was blocking out the sun, and vaporized rock released sulfur, which then led to acid rain and the acidification of the oceans. But there was an even bigger fella that came before that one. Around 2 billion years ago, a gigantic asteroid crashed into our planet and left a massive crater in South Africa. The one we know today as the Redefort crater. And it seems this asteroid might have been even bigger than we all originally thought. Twice as wide as the space rock that erased dinosaurs. The Redefort crater is confirmed to be the biggest visible crater on Earth, with a diameter of about 99 miles. It used to be even bigger when it first formed, though. Maybe even 155 to 174 miles across. It's hard to figure out its true size because the crater has been eroding for the past 2 billion years. Think of it like slicing off layers from the rim of a bowl. The diameter gets smaller with each slice. When the asteroid, 7 to 5 miles wide, that wiped away dinosaurs hit Earth about 66 million years ago, it caused massive destruction. Forest fires, acid rain, tsunamis, and so much ash and dust that it changed Earth's climate. This all made about 75% of life on our planet extinct. The asteroid that created the Redefort crater was not only bigger, but it also traveled at a higher speed, which means the consequences there would have been even worse. But it happened a long time ago, and living beings were different back then. Maybe it was some bacteria that didn't even notice that something unusual was happening. Earth is not the only one. Lots of impacts have happened across our solar system too. For example, in our close neighborhood. Moving to Mercury and its massive crater called the Coronae Basin. It measures about 950 miles across, which is more than the state of Texas. There's a ring of towering mountains around the crater which makes it look even more impressive. You can see different colors in the mosaic image of the Coronae Basin. They tell us more about the geology of the basin. The orange parts represent lava that once flooded the basin. These lava flows covered the original surface and added this specific orange hue. And after the lava flooded the basin on Mercury, smaller craters formed on top of the lava surface. These craters dug into the ground and uncovered the material hidden beneath the lava. Some of this material is blue in color. And this blue stuff could be a clue about what the original floor of the basin had looked like before the lava covered it. Venus, the hottest planet in our solar system, has a thick atmosphere that comes with a pretty good defense system against space rocks. It's so dense that it burns up most meteors before they even reach its surface. As a result, you won't see as many visible craters on Venus as on other rocky planets in our solar system. But Venus still has some scars that can tell us about some serious impacts that happened there. And one of the biggest scars we know about is Meade Crater. It's enormous, about 170 miles in diameter. The inner floor of this crater is relatively flat and kind of brighter than its surroundings. It's possible that the crater ended up filled with a mixture of melted rock after the impact, and maybe even lava from volcanic activity on Venus. Want to get an idea of what Earth might look like without its protective layer called atmosphere? Just take a look at the Moon. Its surface is littered with impact craters. This Tycho is one of the craters you'll easily notice on the Moon. When you look at the full Moon, you can spot it as a distinct circle with bright rays that radiate outward, slightly off-center on the lower left side of the Moon. This crater, 53 miles wide, has a beautiful central peak in the middle that's topped with an intriguing boulder. The size of this boulder is impressive. It would fill about half of a typical city block here on Earth. When talking about craters, we definitely can't leave out Mars. The red planet has a much thinner atmosphere than Earth. When spacecraft approach Mars, they rely on the planet's atmosphere to slow them down as they enter it. And indeed, the atmosphere helps slow spacecraft down during landing, but it's still not thick enough to completely protect Mars from all those space rocks that are coming all the time. From July to September 2018, a dark spot appeared on the southern pole of Mars. It consists of two distinct patterns. A theory says that the bigger, lighter-colored blast pattern can be the result of an impact shock wave scouring the ice surface. The impact generated winds that spread out and scoured the ice. The inner blast pattern, which is darker in color, occurred because the impacting object managed to penetrate the thin ice layer. As it hit the surface, it sent dark sand and debris flying in all directions.
Asteroids aren't as rare on our planet as we may think. About 17,000 of them visit us every year. You've probably seen at least one in your life. For example, if you've seen a shooting star. They leave these bright tails behind them as they pass through Earth's atmosphere. Of course, they only look beautiful in the sky. If they reach the ground, the consequences would be catastrophic. Luckily for us, most of them explode 30 to 50 miles above the surface. Their mass is too small for them to withstand such a journey to the end, so most of them remain harmless to us. But we shouldn't underestimate them. Let's start with the smallest ones. 1 to 3 foot high asteroids are about the size of a person. They're too small to cause any real damage. Most often they explode in the atmosphere without even reaching its lower layers. But at the same time, they splash up tons of energy over the surface every time. 13 to 15 foot asteroids, the height of giraffes and mammoths. These larger meteorites come to us less often, once a year and a half. Like the previous ones, they, fortunately, don't pose a serious threat, but they splash out much more energy. 30 feet. the height of a 3 to 4 story building. They visit us once every 10 years, and now we're talking seriously. It throws out a wave that could demolish an entire city. I think you understand how catastrophic the consequences would be if this asteroid touched Earth. 65 feet, multi-story building. They like to visit Earth once every 60 to 70 years. Good news, it explodes at 12 miles above the ground. Its released energy could destroy an entire region if it touched the ground. Bad news, such an asteroid has already visited us recently, and the consequences were pretty rough. It all happened in a city called Chelyabinsk. On February 15, 2013, at about 9:20 a.m. local time, the giant slowed down in the Earth's atmosphere and then broke up into small pieces at 14.5 miles above the Earth. These pieces then flew in different directions. It shattered the windows all over the city and damaged many buildings, including people's houses, schools, and others. It took a while to repair everything, and the scale of this destruction was quite serious. As a result, there were 1,615 injured. But fortunately, no casualties. At least we're safe for the time being. The next such asteroid may come to us only in the 2070s or 80s, and no one knows where exactly it wants to land. Now let's move on. 300 feet. This is the height of the Statue of Liberty together with the pedestal. Such a giant can be seen every 4,500 years, and this is the first asteroid on our list that may literally crash into Earth. The consequences are disastrous. Not only may it demolish an entire city, but it can also set fire to neighboring areas. Well, some people even witnessed such a meteorite land on our planet. The notorious Tunguska meteorite is the biggest asteroid disaster that people have ever seen. It all happened on June 30th, 1908 in eastern Siberia. The meteorite was bright, like a second sun, and people felt the heat wave when it just approached the Earth. It exploded near the river. Fortunately, the whole area was surrounded by taiga, and there were no big cities nearby. But even there, it immediately destroyed a lot of trees. Serious forest fires broke out. The sound of the explosion was heard by people hundreds of miles around. At tens of miles around, all the houses' windows broke. The magnetic storm that resulted from this collision lasted 5 hours. The consequences were truly disastrous, but perhaps this is not the worst thing that awaits humankind. 99942 Apophis, 1,215 feet. It's slightly bigger than the Eiffel Tower. This meteorite, as scientists discovered in 2013, will be our next guest. Collisions of such force occur in about 100,000 years, and this one is gradually approaching. The force of such an explosion is equal to the force of the catastrophic eruption of the Krakatoa volcano in 1883. This eruption is considered one of the most destructive in history. It caused a terrible tsunami. 165 cities and settlements were completely destroyed, and another 132 were seriously damaged. People all around the globe could feel the consequences of this eruption, at least to some degree. Such an asteroid could leave a 3.5-mile crater, and this is one we'll face in the distant future. But calm down, no need to panic yet. By 2070, the meteorite will be almost 174 million miles away from us. It still has a very long journey ahead of it, so we're safe for at least 100 years, or even more. Besides, our planet has survived something even worse. 3,280 feet. This is higher than the tallest tower in the world, the Dubai Burj Khalifa Tower. Such collisions occur once every 500,000 years. We're not sure when such a collision occurred the last time. 70% of our planet is covered with water. If such meteorites fell into the ocean, it would be extremely difficult to find their traces. But we can assume the possible consequences. The wave would have swept across the entire hemisphere. The crater would be about 9 miles in diameter, and that would be a complete disaster. The last event of such a force happened 26 to 28 million years ago. It was an eruption of the supervolcano La Garita, which is located in the southwest of Colorado, USA. It was one of the most powerful known supervolcanic phenomena in history. During this monstrous eruption, a significant part of the current state of Colorado was destroyed. Scientists are still not sure how far the ashes have spread, but there was an even bigger meteorite in the history of mankind. The consequences of that impact were irreversible for an entire species of animals. I think you know what I'm talking about. Chicxulub meteorite, the thing that wiped the dinosaurs off the face of the Earth. This happened about 66 million years ago. These collisions in general happen about every 500 million years. The height of the Chicxulub meteorite was 12.4 miles. It's so high that when it touched the ground, it could reach the stratosphere. Even looking at the 124-mile diameter crater left by this meteorite, you can understand how huge it was. When it collided with the Earth, millions of tons of energy were released. This is an unimaginable disaster. It fell at a very steep angle, creating a giant cloud of dust and chemicals that spread around the world. This dust had a very thin layer, but also a mass of 50 trillion tons. The shockwave swept across the entire planet. It caused several earthquakes. Volcanoes began to erupt actively. Forest fires broke out everywhere, all over the world. The amount of soot and carbon dioxide released into the atmosphere is invaluable. The Earth was closed from the sun for several days. Darkness reigned all over the planet. Planets couldn't produce enough oxygen, so there was nothing to breathe. The temperature on the continents and in the oceans dropped by an average of 50 to 90 degrees Fahrenheit. Sounds horrific, doesn't it? And, of course, it caused one of the greatest extinctions in the history of the Earth's biosphere. Amazingly, the Earth was able to recover after such a catastrophe. This event became the boundary between the Mesozoic and the Cenozoic eras. So now, those who wondered, how could a small meteorite destroy all the dinosaurs, probably understand the answer. Perhaps the largest collision in the history of our entire planet was not a collision with a meteorite, but with an entire planet. This happened many, many billions of years ago. Theia, as this hypothetical dwarf planet was called, crashed into our Earth, releasing an incommensurable amount of energy, just quadrillions of fuel. The Earth then instantly turned into a giant fire, and it was this collision that led to the creation of the Moon. All that sounds terrifying, I know, so let's just hope that you and I will never see anything like this.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the sun. Bernardinelli Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli Bernstein is too far away from the sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it'd produce a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system. But that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bang! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
From tiny critters to colossal creatures, all animals are trying to escape from a wall of fire moving in their direction. The temperature is rising, and everything around starts catching fire. Soon, lots of animals and plants on Earth will cease to exist. This is the aftermath of a giant asteroid crashing into our planet. But what if dinosaurs had had critical thinking skills? They could have guessed what was going to happen, because this asteroid was visible a year before the impact. 1 year before the impact. With no city lights, all bright spots in the sky are stars. Some of them are planets reflecting the light coming from the sun, like Mars. But one of these dots is the asteroid. Later, it's going to be known as Chicxulub Impactor. It got this name because of the region of modern-day Mexico where it fell. Anyway, at this point, the asteroid looks like a star. It has the same brightness as Neptune. You could even have photographed it with a high-quality camera. If only dinosaurs had thumbs. The impactor is now passing through Jupiter's orbit. From this distance, Earth looks like a pale blue dot. 1 month before impact. The asteroid has become much brighter. It's now the most brilliant spot in the night sky after the Moon. The asteroid crosses the orbit of Mars. Its tail, consisting of dust and gas, is getting longer and longer. It's now as long as 2 times the distance from Earth to the Moon. 1 week before the impact. The intruder's tail is now 5 times the distance from the Earth to the Moon, but the dinosaurs can't appreciate its beauty. To them, it's just another bright dot in the night sky. If this asteroid were flying toward Earth right now, scientists could pinpoint the exact location of its impact within a mile. Then we would evacuate people from the impact area and avoid a major catastrophe. 1 day before the impact. The Chicxulub Impactor now holds first place among the brightest objects in the sky. The light surrounding it, called a halo, seems even bigger than the Moon itself. The asteroid is now passing through the Moon's orbit. It looks like a bright spot that leaves an ashy trail behind it. 1 hour before the impact. The light from the Chicxulub Impactor is brighter than the full Moon, and its movement can be seen with the unaided eye. Nights on Earth aren't dark anymore. Only now, dinosaurs begin to feel anxious. All animals on Earth start to seek shelter. 10 minutes before the impact. The asteroid is now passing through Earth's orbit. Thousands of small fragments from its tail begin to fall on the planet. It looks like a meteor shower. So far, these fragments are too small. They all burn up in the atmosphere before reaching the surface of the planet. The asteroid is approaching South America. If someone was looking at it from Europe, it looked like a sunset. The bright dot of the Chicxulub Impactor is falling behind the horizon. 2 minutes before the impact. Dinosaurs can now easily see the asteroid's shape. If they knew how to do it, they could even estimate its size. It's a bit more than 6 miles across, which means it's almost the size of Manhattan Island, and the giant's weight is 15 plus 15 zeros pounds. It's flying toward the Yucatan Peninsula at a mind-boggling 7.5 miles per second. At that speed, you could get from New York to Los Angeles in around 10 minutes, but you'd kind of burn up on the way. 10 seconds before the impact. The Chicxulub Impactor is now approaching the ground. A few more feet and bam! the night sky suddenly turns white. The flash is so bright that the sun isn't visible at this point. The asteroid's entry causes a powerful blast that can be heard on the other side of the world. The huge asteroid begins to burn because of friction with the air. It heats up and splits into many pieces. These pieces shower on Earth. After a few seconds, the largest part of the meteorite hits the ground. Its mass and speed provide the Chicxulub impactor with an enormous amount of energy. In the next moment, a super powerful explosion shakes the ground. The blast wave from the meteorite begins to spread out from the impact site. It rips out huge chunks of soil and trees and then pushes them to the ground like dominoes. The temperature of the blast wave is so high that everything around the impact site catches fire. The energy released during the collision also penetrates deep into the planet. This causes the strongest earthquakes in our planet's history. They in turn generate tsunami waves as high as the Empire State Building. 5 minutes after the impact, the meteorite leaves behind a huge crater. It's as wide as Lake Huron and deep enough to fit inside 2.5 Mount Everests. Dinosaurs are running around in panic. They try to evacuate toward North America, but most of them don't make it through unfamiliar swampy territories. Another danger is the ongoing meteor shower. Hundreds of tons of ash and debris rise into the air. Heated up by high temperatures, they fall to Earth in the form of liquid lava. Ash and smoke fill the atmosphere and block the sun's rays. Earth plunges into darkness. For several more weeks, our planet will be totally dark. Acid rains will fall on its surface non-stop. There was a lot of sulfur in underground deposits on the Yucatan Peninsula. The energy of the explosion evaporated all this sulfur. Now it's cooling in the air, gathering in clouds, and dripping to the ground. Most animals survive the impact, but the mass extinction continues for many more months. The collision has plunged Earth into darkness, and this has wiped out most of the plants that fed on sunlight. The plant-eating dinosaurs have lost their main food source and begin to disappear. But plant-eating dinosaurs are the main diet of meat-eaters, and now dinosaurs like T-Rex have nothing to eat. Soon, they go extinct too. In other words, it wasn't a meteorite that wiped out dinosaurs, but hunger and climate change. Meteorites of this size fall once every 100 million years. It means that such an event might happen again. Will humans manage to survive this disaster? These days, we can look out far into space, and the appearance of an asteroid the size of the Chicxulub impactor won't be a surprise to astronomers. In general, asteroids that are more than 460 feet across are considered potentially dangerous. Anyway, if we know about the approaching space body, we'll be able to build shelters filled with food and water supplies. Once the asteroid is close enough, we can wait for the impact and its consequences inside. But when people come back to the surface, they'll see cities and towns torn down. Our planet will look like a lifeless desert. That's why we need another alternative, which is to prevent the impact. Here, we have many options depending on the size and material of the asteroid. According to NASA, the most effective way is a kinetic ram. We'll need to send a fairly large and heavy object, such as a spaceship, into space. When it approaches the asteroid, scientists will choose the perfect trajectory, and the ship will crash into the space body. A powerful collision will change the asteroid's course, making it fly past Earth. The further this space body is from our planet, the easier it'll be to send it away. Another option is a controlled explosion on the surface of the asteroid. Newton's first law of motion will help us here. It says if a body is moving at a constant speed in a straight line, it will keep moving that way unless it is acted upon by a force. So, if we make a big enough explosion, or force, the asteroid will shift its trajectory. How much it moves depends on the amount of force applied to it. We can also blast the asteroid right from inside. In this case, there will be no need to change its trajectory. Instead, we'll try to turn one huge hunk of rock into a bunch of smaller fragments. They will burn up in the atmosphere and do no harm to our planet. Another way is a gravity tug. Every heavy object has its own gravitational force and gravitational field. Our goal will be to send a spacecraft to the asteroid and make it fly close to the intruder. The asteroid will attract the spaceship, but its engines will resist. As a result, the ship will slowly but surely pull the asteroid toward itself. This method will take much longer, but gradually, the trajectory of the asteroid will change and it won't crash into Earth, hopefully. We can also use solar power. We can build a spaceship with a system of giant magnifying lenses. Then we'll send that station closer to the Sun. When we spot an asteroid, we'll point the lens in its direction and focus the beam on the space body. The heat from the Sun will cause the asteroid's material to evaporate. Eventually, this will make the intruder change its trajectory. You look up and see a bright orange flash in the sky. A bit later, you hear a boom so loud the window panes around you burst into pieces. And then you see it. A giant piece of space rock burning high above your head, heading for Earth. When it touches the surface, the explosion leaves behind an enormous crater. It's 12 miles deep and as wide as Lake Michigan. After that, 3/4 of all living organisms on our planet are on the edge of survival. This event took place about 66 million years ago, and the bright flash in the sky was the very asteroid that wiped out the dinosaurs. These days, people have many ways to protect themselves, like we could hide in bunkers deep underground and survive. Such bunkers would already come in handy since there are many asteroids in the sky, and some of them are just waiting for their ticket to Earth to wreak some havoc. For example, the asteroid 1990 Mu. In 2027, it'll come alarmingly close to our planet. Many people fear that Earth's gravitational pull will trap the rock, which is the size of 2 Brooklyn bridges. In this case, it'll start to move closer and eventually crash into the planet's surface. Such an impact would cause a shock wave that would be felt on other continents. Once the asteroid hit the ground, there would be an explosion. It'd be so bright, people would think a new sun appeared right here on Earth. The collision would release a huge amount of energy that would then turn into heat. Everything around the impact site would catch fire. And if the asteroid fell in the water, it would cause tsunami waves higher than the Empire State Building. Many coastal cities would be flooded. The dust that would rise after the explosion would cover the sun. The world would be plunged into darkness. If the dust stayed in the air long enough, the climate on the planet would change and Earth would start to freeze. If you think such a small meteorite can't cause serious damage, look at the Chelyabinsk meteor. It hit the Earth in the winter of 2013. When the space rock entered the atmosphere, people miles away heard a loud bang. The brightly burning object was approaching the surface at about 11 miles per second. Halfway through the flight, it split into several pieces. This caused several stronger shock waves. When the meteorites hit the ground, it caused a major earthquake, and the aftershock from the explosions shattered the windows of 5,000 buildings. People in 6 cities around the crash site felt the aftereffects of the fall, and this meteorite was only 60 feet wide. Fortunately, the asteroid 1990 Mu will move past our planet. We'll be safe. Whew! But the next asteroid to approach Earth is going to be 3 miles wide. It's called 3122 Florence. If this giant hit our planet, it could wipe entire continents off the face of the Earth. In 2017, this space rock got awfully close to us. It could be seen in the sky even with a small telescope. Now, the next asteroid is the biggest one to worry about, 1999 JM8. It's about as wide as Manhattan, and it has an unnerving habit of approaching Earth a bit too close for everyone's liking. A small asteroid named 2020 VT4 got closer to our planet than all others have ever done. In November 2020, it flew over the Pacific Ocean at an altitude a bit smaller than the distance from Los Angeles to Las Vegas. That space rock was about the size of a big car. If it did make it to Earth's atmosphere, it would burn up completely before touching the ground. Falling asteroids and meteorites aren't uncommon on our planet. Luckily, most of them burst into flames and burn up before they enter the atmosphere. Mars is to blame for such frequent meteor showers. The planet isn't far from the main asteroid belt in the solar system. Sometimes, the gravitational pull of the red planet grabs asteroids from there. Then, Mars spins them around and flings them in our direction, just like a slingshot. So, Mars is a bully. Good thing we're protected by Jupiter. It's the largest planet in our solar system, and it has an incredibly strong gravitational field. It keeps the asteroid belt in line and protects us from being constantly hit by a rain of meteorites. And that's good news. considering Ceres is in the asteroid belt. This enormous space rock is so big that it was once considered to be a planet. Then, for many years, scientists called Ceres an asteroid. But in 2006, it was finally classified as a dwarf planet. This space object contains a third of the total mass of the asteroid belt, which is about 4% of the Moon's mass. If Earth were as large as a nickel, Ceres would be about the size of a poppy seed. So, what if an asteroid several miles across was heading toward our planet and people had to stop it? Well, we could break the space rock into smaller pieces. A massive explosion could be used to do this. People wouldn't even need to land on the giant asteroid. Getting close to its surface would be enough. Boom! A powerful burst of energy would split the asteroid into several large pieces and tons of debris. The smallest rocks would burn in the heat released in the blast, and it would also change the asteroid's trajectory. The larger fragments would burn up while entering the atmosphere. All witnesses of this unusual meteor shower would have a chance to admire a beautiful fire show. Another means of protection could be a kinetic battering ram. Simply put, it would be a huge object that people would send towards the asteroid approaching Earth. Or it could be a heavy spaceship. This is the method scientists produced to prevent the asteroid Apophis from falling to Earth. This guy is 1,200 feet across and often passes by our planet, coming as close as 19,000 miles above Earth's surface. The asteroid is going to pass close to our planet again in 2029, and there is a possibility that in 3036 it might crash into the Earth. If it happened, the explosion would leave a crater more than 3 miles across. Within 6 miles of the impact zone, all buildings and subway tunnels would be crushed or severely damaged. The event would also trigger a powerful earthquake. In the area of 30 miles away from the crater, car windows and window panes in houses would be shattered. And 75 miles away from the impact site, the earthquake would move furniture and buildings. One way to stop such a catastrophe is to build a heavy spaceship. It would take off from Earth, speed up, and then ram into the asteroid with great force. This impact would alter the course of the huge space rock, and it would fly past our planet. We could also try to stop the asteroid by wrapping it in foil. This would make its surface reflective, and then solar pressure might gradually change the asteroid's trajectory. Another alternative is using the gravitational tug. In this case, we would send an unmanned spaceship, large and heavy, toward the asteroid. It would fly over the space rock and slowly draw the thing closer with its gravitational pull. A small change, of course, would be enough to make the asteroid fly past our planet. Another way to protect Earth would be to build a system of giant lenses in space. Perhaps you've tried focusing sunlight with eyeglass lenses. Then you know how hot this sunlight can get. Now imagine having many giant lenses that are all directed at one point. Scientists think that focusing such a powerful beam of light on the asteroid would make the rock melt and evaporate, slowly changing its route. And one more way to protect ourselves from the asteroid would be to install several rocket engines on its surface. It would turn the space object into a rocket, and we could set its course from Earth. Rogue stars pose a much bigger danger. Like asteroids, they fly through space and can collide with anything in their path. The problem is that they have a gigantic mass, sometimes comparable to our Sun's. Around 70,000 years ago, a duo of rogue stars whooshed past the Sun. It didn't affect Earth, but caused some disturbance on the outskirts of the solar system. This event is likely to happen again someday. The rogue star Gliese 710, about half the mass of our Sun, is moving toward our solar system right now. There's a possibility that it'll begin to grab asteroids from the outer asteroid belt and toss them at us. And then, rare meteor showers you can observe these days will become a regular occurrence. But right now, this rogue star is extremely far from our world, and there's a bigger chance that it'll pass by without affecting our peaceful existence. Boom! An explosion of supersonic waves, interplanetary heat, dust, fumes. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. A few seconds ago, this rock, weighing trillions of tons, was hurtling towards Earth. It could fly from New York to Anchorage faster than you could fry yourself an omelet. This monster's name? The Chicxulub Incident. Epic name, right? 66 million years ago, it crashed into the Earth. Back then, dinosaurs ruled the planet, but not for long. The epic collision took place in modern Mexico, in the Yucatan Peninsula, right near Cancun, where the dinosaurs were vacationing. Well, probably not. Still, the huge space rock hit the ocean, but even all that water couldn't stop the inevitable. The collision caused a huge amount of energy to be released. The horror on a planetary scale had begun. Imagine a mini-sun lighting up the surface of the Earth with tsunamis the height of the Statue of Liberty bursting from the epicenter of the watery impact. Not good. The blast blew through the surface of the Earth. It was as hot as an oven and burnt everything in its path. The impact provoked a colossal earthquake and serious volcanic activity. A bunch of volcanoes simultaneously released hot lava and ash into the prehistoric skies. Millions of tons of ash and soot poisoned the air. This formed a huge ash cloud in the atmosphere, which blocked out the sun's rays for several years. The long winter had begun. Only there wasn't any snow falling from the sky, but rain made of sulfuric acid. Yes, the Chicxulub incident might just be the most important thing that ever happened in the history of our planet. Even more than YouTube. Back then, there were loads of volcanic eruptions, a lot of flammable oxygen in the atmosphere, constant temperature changes. It was the perfect and worst time for all of this to go down. So, how are we so sure about all this? Well, the asteroid left an absolutely huge crater on the planet's surface. Today, this scar is hidden under the Gulf of Mexico. Scientists found a lot of places on Earth with abnormally high levels of iridium. This metal is very rare on Earth, but it's in a lot of asteroids that scientists have examined. Scientists studied some 66 million-year-old rocks. In the layers of rock, they found dust, the same dust that comes from asteroids. This could only have happened if a huge asteroid had crashed into Earth. The catastrophe led to the extinction of not only the dinosaurs, but also the asteroid. It was so hot at the point of impact, part of the asteroid just disappeared. A lot of water vapor and carbon dioxide shot up into the atmosphere. But the biggest problem, sulfur. It got kicked up by the asteroid impact and flew up into the air. These tiny sulfur particles blocked out a lot of the sun's rays. Without the sun, a lot of plants disappeared and the climate eventually got colder. The immense heat turned stones into glass. Scientists call these things tektites. The energy of the impact threw them up into the skies. After a short flight, the tektites fell down to Earth. But it wasn't pretty. Rain fell too, only instead of drops of water, you'd have seen hot glassy fireballs. They bombarded the planet's surface for days. The tektites set fire to everything. Scientists found evidence of this all over the world, not just near the collision site. But a lot of things from back then are still a mystery. Some scientists think that Chicxulub wasn't even an asteroid. It might have been a comet. Asteroids are mostly made of stone and metal. Most often they kind of look like a potato. A comet contains rock, metal, and ice. Comets look like dirty cosmic snowflakes, complete with ammonia, methane, and carbon dioxide. Comets sometimes come from the Oort cloud. It's a huge cloud of ice and debris around our solar system. From time to time, comets break free from the pack and head towards our sun. According to scientists, this special comet flew right past Jupiter. The gravity of that huge planet accelerated the comet even more. It flew towards the sun, gaining more and more speed. The comet's outer ice shield started to evaporate, and it probably gave off a lot of dust and gas, which made it look like it had a tail. The sun's gravity eventually shattered the comet apart. One of the fragments flew through space and crashed into the Earth 66 million years ago. So, asteroid or comet? The truth is, we'll never know. What we do know is that the Earth was seriously unlucky to be in its path, and it was never the same again. The catastrophe stopped the development of 75% of life on Earth. Some bigger marine animals, like crocodiles, turtles, and fish, survived the impact. Out of all land animals, the only ones to survive were the ones that were, on average, smaller than the modern raccoon. That includes a bunch of special species of dinosaurs, the ancient ancestors of birds. Scientists believe they survived for two reasons. After the huge impact, it took a long time for plants to start growing again, and a lot of animals didn't survive. Most remaining animals didn't have enough food. But these dinosaurs had a beak. With its help, they could split open nuts and dig seeds out of the soil, so they survived. The second reason is that these lucky guys had bigger brains. Some people think that they were able to cooperate with each other and quickly adapt to the new conditions. Other life forms survived too. Fungi and mold survived underground and underwater. Gradually, the darkness cleared away, and ferns began to take over the lifeless landscape. After a few thousand years, forests started to reappear. The animals that survived were pretty much all inconspicuous and small creatures. They lived in burrows, safe from all that hot ash. Before the collision, mammals had lived in the shadow of dinosaurs. But with all the dinosaurs suddenly gone, things were about to change. Mammals were able to take over. They began to dominate life, at least on land. Back to the moment when everything changed. Turns out, it wasn't the size of the asteroid that made it so powerful. It was more about the angle in which it hit the Earth. If the angle of impact had been different, the dinosaurs might have even survived the catastrophe. So, what would that have looked like? Well, let's travel back, way back. Oh no, there's a giant asteroid heading for Earth. Oh, wait, never mind, it missed. Whew. There are plenty of earthquakes, tsunamis, and volcanic eruptions every day, but dinosaurs don't mind that much. No big deal. Fast forward a few million years, and most of these ancient lizards have changed and are now unrecognizable. Thanks to a couple of ice ages, many dinosaurs are now totally covered with feathers to protect them from the cold. Mammals exist, but they're few and far between. You see a lot of bats in caves. There are tons of rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, no elephants, or other large mammals. Why become large and eatable when there are so many dangerous reptiles with huge fangs around? There are no whales in the sea. Parrots, hawks, and pigeons are nowhere to be seen. But pterodactyls 2.0 whiz past you constantly. Some are about the size of a helicopter, while others are no larger than a swan. There are plenty of primates, but they're in no hurry to climb down from their trees and walk on two legs. No venturing out into the savannah, no evolution into Homo sapiens. In this alternate reality, open spaces are very dangerous. But then again, so are forests and trees. Nowhere is safe. To get some delicious primate treats, many smaller dinosaurs learned to climb trees. This was already happening back in the Cretaceous period, right before that huge asteroid just missed Earth. Whew, that would have been an epic collision. Dinosaurs have grown wiser since that near miss. Some are even as smart as a modern chicken. A large brain uses a lot of energy, and that's not always a good strategy for survival. Safer to keep brains small and keep making those teeth bigger and pointier. Experts have started examining the samples of asteroid Bennu, and they've discovered that the space rock might actually be a fragment of an ancient ocean world. At the moment, scientists are still inspecting bagged and tagged chunks of the 4.5 billion-year-old asteroid. They were collected in space and brought to our planet by NASA's Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer mission, also known as OSIRIS-REx. This 7-year-long voyage brought the samples in a return canister that came to a full stop on the 24th of September, 2023. It parachuted into a remote stretch of land in Utah. Scientists at the University of Arizona got roughly 7,000th of an ounce of the asteroid Bennu sample for analysis. There were over 1,000 particles greater than 0.02 inches and 28 particles greater than 0.4 inches. The largest particle was 1.4 inches. It's considered to be an awesome collection, full of relatively large stones. The OSIRIS-REx sample is the biggest carbon-rich asteroid sample that has ever been brought to our planet. It also contains nitrogen, sulfur, and phosphorus. This space rock might help researchers investigate the origins of life on Earth. What makes the asteroid material so unique is the fact that it was captured in space. Most meteorites have to endure a fiery fall through the atmosphere of our planet, and we can only get our hands on their changed bits and pieces. Plus, OSIRIS-REx samples have a phosphate crust never seen in meteorites before. Such high concentrations of phosphate have been previously detected in extraterrestrial ocean worlds. For example, Saturn's moon Enceladus contains phosphates, which is a key building block of life. It makes scientists think that Bennu could be a fragment of an ancient ocean world, too. Even though a lot of work is needed to understand the nature of the carbon compounds found in the asteroid pieces, the whole discovery looks promising. It can offer us insights into how the solar system was formed and how life might have been seeded on Earth. The goal of the OSIRIS-REx mission was to get at least 2 ounces of asteroid material. Experts at NASA were working in new clean rooms constructed especially for this purpose for 10 days in a row, carefully disassembling the sample. Interestingly, when the canister lid was first opened, scientists discovered some bonus asteroid material covering the collector head, canister lid, and its base. There was so much additional material that it slowed down the process of collecting the primary samples. Luckily, NASA's scientists and engineers have been working side by side for years, developing specialized glove boxes and tools that could keep the asteroid material pristine. Within the first 2 weeks, researchers made some quick-look analyses of the initial material. They collected images from a scanning electron microscope, examined infrared measurements, and conducted a chemical elements analysis. X-ray computed tomography was used to produce a 3D computer model of one of the particles. Exactly these early glimpses provided the evidence that the sample contained pretty much carbon and water. Scientists believe that the carbon-rich material, with quite a lot of water-bearing clay minerals, is just the tip of the cosmic iceberg. They hope that each new revelation from Bennu will bring us closer to unraveling the mysteries of our space heritage. For the next few years, the mission's science team will keep characterizing the samples and conducting analyses needed to make more discoveries. NASA is going to preserve at least 70% of the sample. As part of the OSIRIS-REx program, more than 200 scientists all over the world will explore the properties of the regolith. Almost everything scientists at NASA do is dedicated to figuring out who we are and where we come from. And such missions can also improve our understanding of space wanderers that might threaten Earth.
The sun is rising, lighting up the trees, swamps, and massive plants of the Yucatan Peninsula. It's 66 million years before today, the last days of the Mesozoic era. This peaceful world doesn't yet know that a rock the size of a mountain is nearing Earth at a speed of more than 40,000 miles per hour. It looks like a fireball that's growing larger and larger with every passing minute. Soon, it already seems to be bigger than the sun. Dinos, roaming the prehistoric Earth, don't know that they have to run, hide, save themselves. Not that it's going to help. The asteroid slams into the planet with enormous force. It doesn't stop moving until it gets through the crust to a depth of several miles. The impact leaves a crater that's more than 100 miles across. Thousands of cubic miles of solid rock instantly turn into vapor. The crash sets off a series of natural disasters that erase 80% of life on Earth. It's the very asteroid that's going to finish off the dinosaurs. All the creatures close enough to see the crash don't survive for longer than a few seconds, so powerful the hit is. Closer to the impact crater, the ground is covered with thousands of feet of hot ash, grit, and rubble. 9 seconds later, and everything for many miles around, grass, trees, shrubbery, bursts into flames. What isn't burned down within the next several minutes after the collision gets flooded. In some places, tsunami waves reach a height of 1,000 feet. Earthquakes are starting to shake Earth like never before. Their power is equivalent to all the earthquakes that have happened on the planet in the past 2 centuries, if they were going off simultaneously. A bit less than an hour after the collision, a gust of wind whips through the area at a speed of 600 miles per hour. It flattens down everything that has been left standing and scatters debris for miles around. A bit farther from the direct impact zone, the skies start to darken dramatically. What looks like shooting stars is actually debris raining back on the planet. Glowing ominous red, they re-enter Earth's atmosphere and emit infrared radiation. During the first hours after the crash, the sky is almost totally dark. Later, it starts to get lighter, very, very slowly. For the next couple of years, it's something between a cloudy day and twilight. Lots of plants don't survive this dimness and the absence of sunlight. The ash stays in the air for months. That's why when it rains, the water is highly acidic. Fires keep raging. They produce tons of toxins that destroy the ozone layer, at least for some time. Earth is in for hard times. More than 30,000 objects that are circling Earth these days can potentially strike our planet. NASA considers around 1,500 of them potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. If one of these objects hits our planet, the consequences will be unpredictable. They can vary from shattered glass and broken windows to all life forms getting wiped off the face of the Earth. Unfortunately, in our case, it's likely to be the second option. In 2004, astronomers discovered a huge asteroid nearing Earth. The first observations showed that the chance of the space rock hitting our planet was a bit less than 3%. The asteroid was named Apophis. It's more than 1,100 feet across and weighs about 20 million tons. It's supposed to streak across the sky exactly on Friday, April 13th, 2029. Apophis will pass at a distance of 19,000 miles away from Earth's surface. Scientists are almost positive that the intruder won't collide with our planet. What's more, they're super excited about the possibility to see this space object close up. And not only them, up to 2 billion people will be able to watch the asteroid pass with the naked eye. But even though this space rock might miss our planet in 2029, it doesn't mean it won't return 7 years later, in 2036. That's when life as we know it might no longer exist. Earth's gravitational pull is likely to bring the asteroid closer, and when it comes back almost a decade later, it's going to be on a closer collision course. Then, what would happen if Apophis or any other asteroid its size crashed into our planet? It would hurtle down to Earth at a speed of more than 1,000 miles per hour. Because of its huge size, air friction wouldn't be able to slow down the invader. Earth's crust would finally stop the asteroid. The impact would turn into vapor not only the space rock itself, but also a huge chunk of the planet's crust. The collision would flatten even reinforced concrete buildings many miles away from the crater. If the asteroid landed in the ocean, the tidal waves would reach several hundred feet. They would cleanly scrub nearby coastlines. Some debris would travel so fast they'd leave the atmosphere and start to orbit Earth. But most of the rubble would rain back to the planet. This would be heating the atmosphere until it got as hot as an oven. Wildfires would be spreading all over the world. Anything not sheltered underground would be cooked in no time. And then, for a year or even longer, Earth would look the same as it did after the asteroid hit it more than 60 million years ago. Ash, soot, no sunlight. A gloomy place. By the way, in 2015, astronomers noticed a 1,300-foot wide asteroid a mere 3 weeks before it passed alarmingly close to our planet. If its course had been a tiny bit different, people wouldn't have had any time to prevent the collision and save themselves. Does that mean that if a similar giant headed toward Earth, we would be doomed? No worries, people would still have a chance to survive. For one thing, we could use a spacecraft to knock this visitor from outer space off its course. Or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight. Or people could probably tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all more or less large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are 3 kinds of missions scientists could prepare at short notice. Type 0. When a heavy spacecraft hurtles toward the intruder with one single goal, to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then, the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods worked, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that would somehow keep air and water fresh. Another option, which doesn't look realistic at the moment, is to go to space. It can't be low Earth orbit, about 1,200 miles above the planet's surface. Debris that would fly up at the impact could easily reach this height. This would probably leave people with 2 options: the Moon or Mars. Sadly, at the moment, we have no idea how to build a self-sustaining space colony, and there's not so much time left to figure it out.
About 800,000 years ago, I wasn't around then, a gigantic asteroid soared through space and plummeted toward Earth. It slammed into our planet with enormous force. It blanketed 10% of Earth with shiny black and green lumps of rocky debris known as tektites. Tektites are pieces of rock that get liquefied by the heat of a meteorite impact. Then they cool down to look like dark, glassy pebbles. A trail of these tektites was strewn across Southeast Asia and reached all the way to eastern Antarctica. This is how scientists know this giant meteorite crash happened. Well, researchers spent nearly 100 years trying to find the gigantic crater caused by the impact. But tektites were too widespread. That's why they couldn't pinpoint the exact location, until recently. A team of experts from different universities tried to discover the ground zero of the meteorite impact. They investigated several craters in China and Cambodia, but none seemed to be created by a meteorite crash. The experts then decided to investigate Laos. It's a country where they discovered the largest and most concentrated number of tektites. After ruling out all visible craters, the team came up with a new theory. What if the crater is hidden by something? In search of the potential crater, the scientists measured gravity readings at different locations all across Laos. At the site of an ancient volcanic eruption, below thick, dense layers of cooled volcanic lava, they discovered a severe gravitational anomaly. It turned out to be a large, elongated crater, over 300 feet deep and spreading 8 miles wide and 11 miles long. Based on the location and the crater's enormous size, scientists believe this is the impact site of the ancient meteorite. Meanwhile, over 2 billion years ago, long before the age of dinosaurs, Earth was struck by one of the largest asteroids to ever hit our planet. The asteroid was approximately 6 to 9 miles across and created the biggest impact crater on Earth. This is the Vredefort crater. You can find it in present-day South Africa. When it was formed, it had a gigantic diameter of 186 miles. Over the centuries, the massive crater slowly eroded away into the Vredefort Dome. That's a rocky hill formation that was the central site of the asteroid's impact. This formation is so large that it can be seen from space. Today, the Vredefort Dome is a recognized World Heritage Site. It's also home to several towns and communities that encourage tourists to come and visit the ancient crater. In 1943, one pilot strayed from his regular flight path to avoid dangerous weather conditions. Flying over Quebec, Canada, he spotted a large, perfectly circular basin. That is how the Pingualuit crater was discovered. Around 1.4 million years ago, a meteorite hit this spot, creating this small but deep impact crater. It has a diameter of 2 miles and a depth of 1,300 feet. A lake of deep blue water has formed at the bottom of the crater. It's said that this lake contains some of the purest water in the world as it has no inlets or outlets. It means that the lake is only filled by rains and melting snow. The lake is home to one species of fish, the Arctic char. The Sudbury Basin is also in Canada. Formed over 1.8 billion years ago, it's one of the largest and oldest impact craters in the world. It's located in Ontario, but the impact from the collision was so powerful that debris from it was found 500 miles away in Minnesota. Unlike most impact craters that have a circular shape, the Sudbury Basin is an oval. It's 39 miles long with a width of 19 miles. The original impact site might have been a whopping 10 miles deep, but its modern-day version is much shallower. The asteroid that created the basin carried a high concentration of natural minerals. This made the soil in the crater incredibly fruitful. Today, its floor is home to numerous fruit and vegetable farms. The unique crater formation of Sudbury Basin was used to train Apollo astronauts before they embarked on their missions to the Moon. Perhaps the most famous meteorite of all is the Chicxulub. That's the meteorite responsible for wiping out 75% of all plant and animal life on Earth, including the dinosaurs. The Chicxulub meteorite had a diameter of 6 miles when it struck Earth 66 million years ago. The crater now lies off the coast of Mexico, hidden deep beneath the seabed. It's around 93 miles across and 12 miles in depth. Recently, scientists managed to drill deep down into the highest peak of the impact crater to collect rock samples. They discovered that the disappearance of dinosaurs wasn't caused by the giant size of the meteorite or the scale of the blast. It was because of the exact location where the Chicxulub hit Earth. The meteorite struck part of our planet that was densely filled with a mineral compound called gypsum. It's a soft sulfate mineral that is typically used as a fertilizer. The collision blasted so much sulfur into the air that it blocked out the sun. This caused the prolonged dark winter that doomed the dinosaurs. One of the youngest craters on Earth is the Barringer crater in Winslow, Arizona. The Barringer crater is also one of the best preserved craters on Earth. It was formed 50,000 years ago when a heavy meteorite made mostly of iron plummeted down from space. Earth's atmosphere barely slowed down the massive chunk of metal. It collided with the ground with incredible force. The meteorite vaporized upon impact, leaving very few remains. The crater left by this powerful explosion was named after the man who identified it in 1903. It was a mining engineer named Daniel Barringer. The diameter of the crater is 3,900 feet and it goes 560 feet deep. The Barringer family still owns the impact site to this day. You can visit the crater and take a guided tour around its rim. The Papagai crater in Siberia is one of the most interesting craters on Earth. An asteroid impact over 35 million years ago formed this massive basin. The crater is 62 miles across, which makes it the fourth largest one in the world. This crater is unique as it's home to one of the largest diamond deposits in the world. The intense pressure from the collision transformed the graphite at the impact site into diamonds. Scientists say that the crater contains trillions of carats of diamonds. but no one has ever mined them due to the site's remote location and lack of infrastructure. In the year 1530 BCE, a meteoroid entered Earth's atmosphere before shattering into pieces. The meteorite's burning fragments rained down on Earth and crashed into the planet's surface. As a result, a group of craters appeared on a small Estonian island, Saaremaa. The largest crater is a 360-foot wide perfect circle. It's 70 feet deep and filled with blue water. 8 smaller craters that appeared during the collision can be found within a half-mile radius of the largest crater. The impact of the meteorite fragments caused the trees on the islands to catch fire. Almost all forests burned down. Luckily, the woodlands have now grown back, and the craters are a popular hiking destination for tourists. A meteorite struck the area we now know as Quebec, Canada, around 200 million years ago. This collision created the 6th largest impact crater in the world. It had a diameter of 40 miles. Over the century, the outer rim of the crater has filled up with water. It's now known as Manicouagan Reservoir. The impact crater lake is so large it can be seen from space, and its strange shape gave the lake its nickname, the Eye of Quebec. The oldest meteorite crater in the world is in Western Australia. The Yarrabuba crater is 2.2 billion years old. Well, that gets my vote for the best crater name. The impact site is so ancient that the original crater has completely eroded away. Yarrabuba's diameter was around 19 to 43 miles. Scientists managed to figure out the age of the impact site by analyzing the ancient crystals and minerals found within the crater.
The problem with that asteroid that destroyed dinosaurs was not that it fell, but where it fell. This colossal space rock found the worst place where it could land. Also, the angle at which it hit the ground was the most unfortunate. If it had fallen vertically, there would have been less destruction. But it fell at such an angle that it threw a huge amount of dust into the air. After the disaster occurred, tons of soot started burning. 65 million years ago, only 13% of Earth's surface contained the right amount of sulfur and oil needed to form a colossal amount of soot. If the asteroid had fallen on the other 87% of the territory, dinosaurs could still be living today, but it hit the worst place and lifted 1 million tons of burning material into the sky. A cloud of incandescent particles covered the sky and set off on a journey across the mainland. Then, these particles settled on the ground and caused large-scale fires. Trees were burning and sending more soot into the sky. But the asteroid collided not only with rocks, it fell on the coast in a place where the seabed was filled with sulfate. As a result of the collision, it started burning, which caused the release of sulfuric acid into the atmosphere. The air became poisoned. It seems the dinosaurs didn't stand a chance. And now, let's imagine the asteroid falling in another place, somewhere in the middle of the ocean. Huge waves flooded part of the land, but almost all kinds of dinosaurs survived. Or even better, the rock could have fallen somewhere in the desert and left behind a giant crater. That's all. Yes, several dinosaurs passing by wouldn't have survived the collision, but the situation wouldn't have been so critical in general. So, giant lizards remain dominant on our planet. They don't allow other animals to develop since Tyrannosaurus and other ferocious reptiles hunt mammoths and other ancient creatures. The population of mammals is decreasing. Velociraptors are fighting for territories with saber-toothed tigers and giant bears. A struggle for survival between dinosaurs and other animals begins. Then, the Ice Age comes, and some reptiles don't survive. Then, new players enter the field. Those are humans' early ancestors. Living side by side with dinosaurs is difficult. Lizards attack settlements and caves, so people have to build high walls for protection. By the way, the Tyrannosaurus poses less danger to people than you might have thought. According to the latest research, many creatures were able to run away from this monster. Yes, you probably saw how easily they caught up with cars in the movies, but it wouldn't be as scary in reality. Paleontologists and biologists have analyzed the strength of dino's bones and found out that the creature couldn't reach high speeds. The maximum it was capable of was running twice as slow as a field athlete. Thousands of years have passed. People have learned to live with dinosaurs. They've even managed to tame some lizards. They've domesticated herbivorous dinosaurs to develop agriculture. Triceratopses and bulls now plow fields together. Imagine farms swarming with diplodocuses or brachiosauruses. People climb their long necks and pick fruit from high trees. Stegosauruses protect pastures from wolves and velociraptors. Dinosaurs with shells, such as ankylosauruses, help people cross deserts. They, along with camels and donkeys, carry heavy loads. People share the planet with ancient lizards and live in harmony. The situation in the seas and oceans is much worse. Sea reptiles attack wooden ships and catch all the fish. Imagine that you're sailing to another continent with tons of grain, fabrics, fur, and other goods. And then a giant mosasaur appears on the horizon. It's one of the most powerful sea lizards. A great white shark looks like a small fish next to it. The creature could easily defeat a megalodon. And then it comes across a wooden ship. It bites into the deck and pulls the whole boat underwater. Water dinosaurs are the main obstacle to communication between countries. This slows the progress down for 100 years. People built metal ships to withstand the attacks of the mosasaur. And finally, they managed to establish sea connections. A similar problem occurs when the first planes take off into the sky. Imagine you're flying on a passenger Boeing. You look out of the window and see a pterodactyl. Wait, it's impossible. These winged lizards aren't so fast, but they can catch up with a helicopter or some old biplanes. This poses a serious threat to flights, so people install sound protection systems on board each aircraft. Pterodactyls hear irritating ultrasound from a distance and fly as far away from it as possible. People equip submarines and ships with the same sound shields. Then, after people have learned how to defend themselves from dinosaurs, another problem appears. Lizards are the kings of wildlife, so they displace all other animal species. Dinosaurs run across African savannas, and lizards with fur live in cold winter forests. Lions, wolves, and bears are not the rulers of the wild. Rhinos fight with Parasaurolophuses. Stegosauruses attack hippos and take away their territories. Venomous dinosaurs live in jungles. Lizards that can climb trees scare monkeys. Imagine a reptilian ape jumping from one branch to another. To save regular animals from extinction, people have to control the population of predatory reptiles. Huge parks and nature reserves appear in all countries. People transport dinosaurs there and separate them from other wildlife. Dinosaurs seem to be completely under control. When the danger caused by giant reptiles passes, people begin to breed smaller, harmless lizards. Someone buys a chameleon, and someone keeps a Microceratus at home. There are dinosaur exhibitions. People take these creatures for a walk as if they were dogs. Some people take selfies with reptiles, go shopping, and sit in cafes with small lizards. Dinosaurs aren't formidable now. They're kinda cute. People ride horses, camels, Parasaurolophuses, and Pachycephalosauruses. Of course, many have tried to tame velociraptors, but failed. Those are dangerous reptiles and they don't know how to obey. Taming them is almost as difficult as taming an alligator. But dogs and cats are still more popular because they're more intelligent. The brain of a dinosaur is almost the same as that of a chicken. But who knows, if they had lived to this day, perhaps they would have evolved into smarter creatures. Just imagine if dinos were intelligent. In this case, people would have a big problem. Some scientists think that even if a meteorite hadn't destroyed the dinosaurs, they wouldn't have survived to this day. They needed to carry their own colossal weight at all times. It was an enormous load on their bones and joints. Most dinosaurs wouldn't have been able to survive the Ice Age with such characteristics, but smaller lizards might have succeeded. Fast and agile dinosaurs, such as velociraptors and Pachycephalosauruses, would have survived, but in what form? Could dinosaurs have already evolved into something else? Look at the good old chicken. Many scientists believe it's a direct descendant of the formidable Tyrannosaurus. Somewhere deep inside the bird's DNA, there are genes that the dinosaur had. Yep, it's hard to believe, but look at the chicken's body structure and how it walks. Remove the plumage, cover the creature with scales, and give it toothy jaws instead of a beak. And now, you have a mini T-Rex in the coop. And by the way, not only chickens might be the relatives of giant lizards, many birds are dinosaurs' living descendants. Surprisingly, alligators, snakes, crocodiles, and monitor lizards are not as close to ancient reptiles as pelicans, storks, and other flying creatures. Over millions of years of evolution, the paws of dinosaurs turned into wings, and toothy elongated jaws ended up as beaks. The genetics of birds is the key to understanding dinosaurs. Pelicans are similar to pterodactyls, ostriches to velociraptors. Perhaps many other animals also share some genes with ancient lizards. If the meteorite hadn't fallen, all dinosaurs would have evolved into completely different, unusual creatures. Scientists want to carefully study the DNA of birds and try to reverse evolution with the help of genetic engineering. They hope to breed dinosaurs out of eggs one day. But to do this, they need to find a specific genome that hasn't changed over tens of millions of years. It hides in the DNA. And it's not so easy to find it and extract it. Do you think we will see powerful reptiles by 2050?
66 million years ago, I wasn't around then, a huge asteroid hit the Earth and triggered the mass extinction of almost all living creatures on the planet, including dinosaurs. Had the space object crashed somewhere else, some dinosaurs would have been able to survive and still live nowadays. According to some research, the asteroid had about 1 in 10 chances of wiping out the dinosaurs and other animals of that time. It was way more likely to just hit the ground without any strong destructive consequences. To understand how things could have turned out if the place of the collision had occurred elsewhere, we need to find out what happened that day and why the disaster turned out to be so devastating. This huge space rock fell into the coastal area of the Yucatan Peninsula in Mexico. This caused a chain reaction that triggered natural disasters around the world. The place the asteroid hit is called Chicxulub Crater. Now half of this area is underwater. The asteroid was about 7.5 miles in diameter and moving at a speed of 27,000 miles per hour. This rock, bigger than Everest, was rushing toward Earth faster than the speed of sound by almost 40 times. Wow. The energy released in the collision was as powerful as an explosion of about 10 billion atomic bombs, and the destructive force of the blast wave was just one of several disasters. The asteroid happened to fall in one of the worst possible places, and because of the way it fell, it threw a huge amount of dust into the air. Imagine you're jumping into the water like a professional athlete vertically, leaving hardly any splashes behind. And now think of how much water splashes when you jump into the pool like a cannonball. So the asteroid landed the cannonball way. The second disaster the asteroid provoked was soot burning. A small part of the Earth's surface consists of rocks. Only a tiny percentage of that part was rich in oil and sulfur back then. The asteroid burned and lifted so much soot into the air that it would be enough to fill an indoor baseball stadium. According to research, 65 million years ago, only 13% of the surface of the entire planet could have contained the necessary amount of organic material for the formation of such a volume of soot. That's why this place was considered the worst. If the catastrophe had happened on the territory of the other 87%, then dinosaurs would have been alive today. A huge cloud of soot and carbon dioxide rose into the air and covered the sun. The soot turned the sky gray and partially blocked sunlight. This led to a quick drop in temperatures almost all over the planet. It seemed like Earth was inside a gray veil. Many plants and animals couldn't survive the cold snap. Trees began to wither because of the lack of sun. The photosynthesis process was disrupted. The cold and withering of trees led to another catastrophe: global famine. Herbivores couldn't survive because they lost almost all of their food. Plants, flowers, and trees didn't manage to get through the catastrophe. These destructions spread far beyond the asteroid impact site. Hot dust particles, asteroid chunks, and small pieces of rocks settled to the ground across the continent and caused large-scale forest fires. Burning trees threw even more soot into the air, which made the situation even worse. The huge asteroid brought heavy metals with an increased level of toxicity from space. The melting of these substances during the collision provoked firestorms. The asteroid didn't only hit continental land but also water, which triggered a huge tsunami. But that's not the worst part. the seabed was filled with sulfate, and when the energy of the asteroid burned it, it provoked the release of sulfuric acid into the atmosphere. The acid cloud mixed with a cloud of soot and began to spread throughout the sky. Hot rock particles were falling to the ground like fire rain. An acid rain started because of sulfur. It lasted for almost several days and left no chance for the animals to survive. Acid rain made the water in rivers, lakes, and seas poisoned. The acid destroyed anything that couldn't burn. A part of the clouds went to wreck the land, and the other part, the ocean. This made the situation even worse, as sulfur droplets wiped out a huge amount of seaweed and phytoplankton. The ocean generates almost half of all oxygen reserves on our planet. Those days, the sea creatures living in its upper parts were destroyed. It wasn't the blast wave, but lack of sun, acid, darkness, and cold that became the main reasons for the extinction of dinosaurs. But even when some lizards escaped from fires and sulfur, they met the sea element. The asteroid impact caused large-scale tsunamis across the planet. The very first wave was around 1 mile in height. That's almost 3 times higher than the Empire State Building. Billions of gallons of water were moving at 90 miles per hour. A wave this strong could easily destroy half of New York today. The meteorite created a series of waves 52 feet high. Massive walls of water the size of 5-story buildings collapsed on the shore and demolished everything in their path. Lack of sunlight, temperature drop, acid and fire rains, reduced oxygen production, forest fires, giant tsunamis, and the explosive wave with the power of 1 billion atomic bombs, all this reduced the biological diversity of Earth by 75%. Yeah, that'll change your climate for sure. Giant asteroids used to hit Earth before, but they never caused such disasters all over the planet. What if this asteroid had fallen into another place, say a forest, far from water and mountainous terrain? This would have caused severe fires. A huge black cloud of ash would have risen into the sky and obscured the sun. But it would have unlikely generated acid or fire rains. Most of the species of the planet could have survived this catastrophe. What if the meteorite had fallen somewhere among the ice and snow? This would have provoked a rapid increase in temperature across the planet. Huge tsunamis would have sunk big tracts of land. However, ash and sulfur dioxide wouldn't have filled the sky. Acid rain wouldn't have hit the ocean. Many marine creatures could have survived and lived to this day. And dinosaurs, far from the oceans, wouldn't have noticed the meteorite fall at all. Probably the most terrible events would have occurred if a meteorite had fallen on an active volcano. This would have triggered the largest lava release in history. Destructive earthquakes would have begun, and the whole sky would have been covered with volcanic ash. What if the meteorite had hit some desert? It would have melted billions of tons of sand and turned it into glass. Just imagine glass dunes that heat our planet even more. And we could dig up the well-preserved remains of ancient lizards out of the glass. Anyway, there were many different possible catastrophic scenarios, and the worst of them came true for the dinosaurs. They are unlikely to return, although perhaps they can be reborn. Scientists were inspired by an idea from a famous Hollywood movie. They wanted to find a mosquito that got stuck in amber. They would extract dinosaur DNA from it. But there was a problem with this. The oldest DNA sample they managed to find was 1 million years old. Dinosaurs were extinct about 66 million years ago. Besides, DNA is a very fragile thing. The probability that it could have been preserved intact somewhere for so long is very small. So, instead of searching for this ancient dinosaur DNA, scientists decided to take DNA from the closest ancestors of these lizards, birds. Over millions of years of evolution, dinosaur paws could have turned into wings, and elongated mouths could have become beaks. Pelicans are very similar to pterodactyls, ostriches resemble velociraptors, and chickens are very much like T-Rex. Okay, let's just stop and imagine for a moment a chicken the size of a T-Rex.
Hey, you want a piece of me?
Now, the common chicken is recognized as the closest relative of the huge lizard. Remove the plumage from it, cover it with scales, give a toothy mouth instead of a beak, and attach a long tail. And you get a real mini Tyrannosaurus rex by body structure and movement. Deep in its DNA, there are similar genes that formidable predators have. With the help of genetic engineering, scientists plan to play with its DNA and try to reverse the evolution, which means breeding dinosaurs can become a reality. Well, that could come back to bite you. In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the Sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, Interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our Sun, the faster it became, releasing that hydrogen and also changing its path through our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it's throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star. Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects, and inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object that might smash into our planet in 159 years. According to the experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If that hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that during the flyby in the 22nd century, there's a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chance of colliding with Earth are quite low at the moment, the space rock has still been categorized as a, quote, potentially hazardous asteroid, all because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that was formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are, as you recall, Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules, similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx managed to briefly touch the surface of the asteroid. It collected some samples and propelled off the space rock afterward. For NASA, it was the first mission of this kind. But it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942, Apophis, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 0.6 miles across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they're moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need some time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only the Earth but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. Now, it might sound a bit scary, but there are around 25,000 asteroids larger than 460 feet in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 160 feet in size. Those are capable of destroying a concentrated urban area, and still fewer than 8% of those have been detected. There are also tens of millions of smaller near-Earth objects. They are larger than 33 feet across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. Now, the thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere, and the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now astronomers can direct the power of the camera towards other tasks. They claim that the DEC's survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system. So, theoretically, humans can survive an asteroid that has the potential to destroy entire planets. It won't be a walk in the park, though. Let's go back in time to 66 million years ago, in the late Cretaceous period. The Earth, before humans, where dinosaurs are thriving. The plants and animals are rich and diverse. You'd see a T-Rex chasing a Triceratops, or the massive Alamosaurus, one of the biggest animals to ever roam the planet, towering over the landscape. In Texas, they remember the Alamosaurus. And watch out for the Ankylosaurus, a living tank swinging its tail like a wrecking ball at any threat. As you're about to enjoy a quiet evening under the stars, a bright new light appears in the sky of the northern hemisphere. Now, a new star in the sky doesn't really stand out at first. It's just twinkling like the rest. But give it a few hours and you'll notice it's getting brighter. Check again the next night and boom, it's the brightest thing in the sky, outshining planets and even the moon. Then finally, it horrifyingly outshines the sun. The star was the Chicxulub asteroid, which left a gigantic crater now called Chicxulub Crater in Mexico's Yucatan Peninsula. The asteroid enters the Earth's atmosphere at a blistering 12.5 miles per second. It blasts through 60 miles of the atmosphere in about 3 seconds. It falls so fast that even the air can't get out of its way. The air gets squashed and heats up to thousands of degrees in a blink. Before the asteroid even touches the ground, this super-hot air has already vaporized much of the sea where it's about to strike, near the Yucatan Peninsula. Then, in a flash, the asteroid smashes into the Earth, screaming over Central America with a loud boom that echoes everywhere. It doesn't just smash the ground, it makes the soil and rock flow like liquid. The asteroid digs a hole so wide and deep that it nearly touches Earth's inner layers and throws up dirt more than 20 miles high. At that exact moment of impact, The asteroid also turns its massive speed and weight into heat in a split second. It puts so much energy into the Earth that it makes molecules move faster than the surface of the Sun. This massive energy created a giant ball of plasma, superhot charged gas that includes bits of vaporized rock. This all shot out at incredible speeds. The shockwave from the impact and the heat turned the Earth around the crash site into gas instantly. This set off earthquakes all around the world. And it's not just the rocks flying around that you need to worry about. As they plummet through the sky, they rub against the air, heating up so much that they set fires all around the world. The heat they give off could be compared to an oven cranked up to its highest setting. This fiery shower causes most of the world's trees to burn down. The entire world is now on fire. Soon it changes everything. In a blink, dinosaurs were wiped out, making way for mammals to rise. And not only dinosaurs, 75% of species and big creatures disappeared, leaving behind only some small birds and critters. So, how could you, a human, survive something like that? Now, some animals made it back then. To survive, we need to learn from their resilience. The only birds that survive even in the toughest conditions are the ones nesting safely on the ground. Among the few larger animals that manage to dodge extinction, all have ways to deal with the heat. Some, like certain small mammals, snakes, and lizards, can dig themselves into cooler underground burrows. Others, like crocodiles and turtles, just hide in the water. So, if you're exactly on the other side of the planet when the strike happens, and you act super fast, you might just make it. Right now, the impact is about 10,000 miles away, but don't underestimate its power. As soon as you hear the loud boom, head underground as quickly as you can. And be careful, because you'll feel the Earth shake about 30 minutes later. Hide in a deep cave, preferably with a narrow entrance. It would protect you from the falling debris, and the temperatures underground would be stable. Also, some caves have natural water sources, rivers or streams. You might also prepare for the not-so-great diet of insects, fungi, or poor small animals that also seek refuge in the cave system. But it's better than nothing. You also need to be extremely far away from any large bodies of water. Being near the ocean might seem like a safe bet during a massive asteroid impact because the sea can buffer extreme temperature changes. But the earthquakes trigger terrifying tsunamis, even in lakes or fjords. The asteroid's crash sets off not just one tsunami, but many, and they're as tall as skyscrapers. Within an hour, colossal waves between 600 and 1,000 feet high hit the Gulf Coast, slamming into places like Mexico and the southern United States, and flooding miles inland. These waves are so powerful, they even push rivers backward. These tsunamis continue around coastlines, reaching the east coast of the United States, and 6 hours later, they hit Europe, Africa, and the Mediterranean. By 15 hours after the impact, there isn't a coastline on Earth that hasn't felt the wrath of these waves. Well, let's say you survived the initial impact somewhere deep underground, but your troubles have only begun. The Chicxulub asteroid strikes a region loaded with sulfur. This sends 100 billion tons of sulfur and an enormous amount of water into the sky. The water vapor forms massive storm clouds. They start to rain acid. In colder places, huge snowstorms bury the land under feet of snow each day. The impact also vaporizes massive amounts of oil, throwing up 150 football stadiums worth of it into the air. This oil turns into a thick black soot in the stratosphere. It coats the Earth like black paint. And even when the acid rain calms down, this carbon stays up above the clouds and doesn't wash away. This sooty layer blocks out 90% of sunlight, plunging the Earth into a cold darkness that lasts for at least 3 years. The world cools down by about 50 degrees on average. Now, when you finally leave your deep cave, you must look for places where you won't freeze. The only spots spared from the frost are tropical islands like Madagascar, India, which was an island back then, and Indonesia. These places have surviving plants and animals, and they even continue to get fresh water, unlike most of the world. Everything else in the world looks like a huge nuclear wasteland. These tropical islands are safe spots during an asteroid apocalypse, but don't think of them as paradise. These places still only get about 10% of their usual sunlight and barely enough rain to avoid turning into deserts. In this chilly, gloomy setting, most food chains fall apart. If you want to survive, you'll need to bring lots of extra food with you, for the next 6 years at least. Now, some things are lucky enough to survive. Fossils tell us that freshwater ecosystems did well, so staying close to a river or estuary might be your best shot at finding food. You could come across turtles, crocodiles, and some fish. Animals like clams, snails, and small crustaceans that live in the sediment also manage to hang on. And while a bit warmer than everything else, these places are no walk in the park. You'd need to pack warm clothes to have any chance of survival. Now, if we add all this together, the best spot for surviving the Chicxulub asteroid would be Indonesia. It's a mountainous, tropical country that consists of several islands. There, you'll find bearable temperatures, a bit of rainwater, and a deep cave for shelter. This could protect you from the falling tektites, the intense heat, and even help you find something to eat in the rivers and lakes. But if you stumble upon any shrew-like creatures while scavenging for food, time traveler, please let them be. It's not clear how many survived the Chicxulub impact, and eating one could have unforeseen effects on the future of humanity. Like, don't eat your great-great-great-great-great-great-grandfather, right?
Living on our beautiful planet might seem safe, but only until you start thinking of all those dangers lurking just around the corner or in the vast darkness of the cosmos. Let's see what may eventually lead to the end of planet Earth. With each new potential threat, it gets more and more terrifying. Consider yourself warned. First of all, let's talk about hypercane. This natural disaster can get really extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or a massive volcanic eruption could trigger it. In any case, these conditions would create a hurricane, which, unlike regular hurricanes, would stretch way beyond the lower stratosphere. The speed of such a storm would reach 500 miles per hour. The pressure inside the hypercane would be so low that it wouldn't let it wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It would likely damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Then we've got super destructive tornadoes. A tornado is a violently rotating column of air. It usually extends from a thunderstorm and is in contact with the ground. Inside a thundercloud, warm, humid air rises upward, and cool air falls down along with rain or hail. Such conditions can lead to the appearance of spinning air currents inside the cloud. Interestingly, these air currents start out horizontal, but at one point they can become vertical and drop down from the cloud, becoming a tornado. Some tornadoes are narrow, rope-like swirls, but others turn into wild funnels. Tornadoes are ranked with the help of the enhanced Fujita scale. A weak tornado normally lasts for a few minutes and doesn't move faster than 100 miles per hour. The next level is a strong tornado. Such whirlwinds can last for 20 minutes or so and have winds of up to 200 miles per hour. And then we can also have violent tornadoes. Those can last for more than an hour and move at a speed of between 200 and 300 miles per hour. On average, around 1,000 tornadoes occur in the USA every year. There's even a region that got named Tornado Alley. It's a 10-state area in the Midwest, but tornadoes can happen in any state. One of the most destructive natural disasters was the tri-state tornado in the USA. It was the world's longest-lasting single tornado that traveled 220 miles through Missouri, Illinois, and Indiana. At the same time, the average tornado's path is usually no longer than 5 miles. But what if one day, a tornado much bigger and way more powerful than any we've experienced before swiped through countries and continents? It would leave behind total destruction and devastation. And how about a supercell thunderstorm? It's the least common type of thunderstorm, but it's the most dangerous. It's likely to cause severe weather, damaging winds, very large hail, and even violent tornadoes. What makes supercells unique is a deep and persistent rotating updraft called a mesocyclone. Supercells can potentially last for hours and cause great havoc. An asteroid impact could end all forms of life on Earth too. If a space wanderer was large enough, it could cause widespread devastation, like it happened with the 9-mile-wide asteroid from 66 million years ago. It's rumored to have destroyed 3/4 of the planet's plant and animal species, including dinosaurs. Depending on the asteroid's size and the speed of its approach, the impact could lead to massive fires, tsunamis, and the eternal winter effect. It happens when the debris ejected into the atmosphere blocks sunlight and disrupts the global climate. Luckily, we'd probably notice such a large asteroid coming close to our planet with the help of our equipment long before the collision and would have enough time to get rid of this threat. It would be our very own sun that would bring our world to an end. Our star is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. Now, if you had gamma-ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, and then disappear again. Those flashes are gamma-ray bursts. One of them could wipe out Earth's atmosphere. The flash that might ruin our planet would most probably be born in a faraway galaxy during a merge of two collapsing stars. It would be immensely powerful and super bright. Still 1,000 light-years from Earth, it'd already shine as bright as the sun. Our planet's atmosphere would try to protect us, but its natural shield wouldn't last. The radiation would be so powerful that it would literally cook the atmosphere. It would create nitrogen oxides that would destroy the ozone layer. Without this layer, ultraviolet rays coming from the sun would be hitting Earth's surface at full force. They would wipe out tiny plankton in the ocean. But these plankton produce from 50 to 70% of all oxygen in the world. So, with their disappearance, there would be a severe lack of oxygen, which would lead to the disappearance of life on the planet. In the end, the heat and ultraviolet light coming from the sun would turn the planet into a huge chunk of rock. And what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest to us black hole is 1,500 light-years away. It seems that we have nothing to worry about until we learn about wandering black holes. Now, things definitely get way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2020, 13 wandering black holes were spotted not so far away from our planet. But not far away in space terms means around 1 billion light-years away, so we've got some time left. Plus, the possibility of such a disaster is very, very low. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the sun. Then, the climate all over the planet would start getting colder and colder. Don't forget that the farther our planet is from the sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Or the sun might expand and turn into a red giant. If it happened, it would change the entire habitable zone of our solar system. The disaster would start with our star running out of hydrogen in its core. This would trigger a chain of reactions, which would eventually lead to the core of the Sun heating up and getting denser. As a result, the Sun would get way larger than it is now. During this transformation, the Sun would swallow Venus, Mercury, and Earth. You get the last instructions from the team and get into your spaceship. It's the first spacecraft made on Earth that can move at a speed close to the speed of light. Your task is to visit the most unusual and terrifying places in space and send scientists detailed information about them. And so, your journey begins. Your spacecraft is accelerating, and you dash past the moon. In the distance, you see a small reddish planet. It's Mars. And look at that spectacular giant surrounded by a set of rings. That's Saturn! You wish you could have more time to explore this gas giant, but you have to hurry. You pass by beautiful stars. Some of them are luminous, others have a reddish hue, and some seem to be dimming. That's Sirius, the brightest star in the night sky on Earth. It's about 8.6 light-years away from us, but you're traveling fast, and soon you see Polaris, aka the North Star, which is way further, 431 light-years away. Sometimes you manage to spot tiny dots circling these stars. Those are planets. And then, suddenly, you see nothing. At first, you're horrified. Something has gone wrong, and you've accidentally entered a black hole? Has your equipment malfunctioned? Because it seems that at a distance of 700 million light-years away from Earth, there's a hole. A blank void with no galaxies, stars, planets, or asteroids. You can't see anything. The void is a roughly spherical region of about 330 million light-years across. Our home Milky Way galaxy could fit in there billions of times over. And then it dawns on you. What you're looking at is the mysterious Boötes void. It lies about 700 million light-years away from Earth in the constellation of Boötes, the herdsman driving the plow around the North Pole. At first, this void was called the Great Nothing, but later it was given its current name. Now we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are ginormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Boötes void is one of the most massive ones. It's even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, all the matter in the universe was packed together quite tightly. Astronomers even think it was something like a uniform soup. But pretty soon, random quantum fluctuations started distributing this matter. Some areas became denser. As a result, their gravitational pull became stronger, and they began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. After staring at nothingness for some time, you decide to explore other space objects and start the engine of your spacecraft again. There's one kind of space formation you've been looking forward to seeing: nebulas. Those are gigantic clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. Sounds familiar, doesn't it? One day, this mass becomes so big that it collapses under its own gravity and forms new stars. So, you decide to visit some of the most beautiful nebulas out there. And you start with the Butterfly Nebula. This butterfly's wingspan is more than 3 light-years. and the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it was formed from a gargantuan star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass or a butterfly. The next place you decide to visit is the Eskimo Nebula, 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and got its name for a reason. Its double shell formation looks like a person's face hidden in a padded hood of a winter jacket. But in reality, this parka is a disk of material with a ring of comet-shaped objects. And the tails of these objects stream away from the star at the center of the Eskimo Nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. As for the Eskimo's face, even though it resembles a ball of twine, in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Your next destination is the Ring Nebula. At first sight, it's a giant cloud of dust and gas surrounding an old, almost extinguished star, which does look like a ring. But astronomers say the nebula isn't a bagel, it's a jelly-filled donut. The deep space colorful object more than 2,000 light-years away from Earth is actually a ring that wraps around a blue, ball-shaped structure. Each end of the structure sticks out of the ring's opposite sides. Now you can head to a place called the Pillars of Creation. You find it more than 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old, space babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called Pillars of Creation, an active star-forming region. And since you've already visited a star-forming region, why don't you drop by a living fossil galaxy? For example, DG-SAT-1. It's as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It can mean that DG-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. The next stop on your space sightseeing tour is the Black Widow Pulsar. Just like its spider namesake, this rotating neutron star is munching on its partner, a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. Oh, look at this! That's a stellar nursery in the constellation of Centaurus. But even though this place might be called nursery, it's anything but peaceful or safe. This region, made up of hydrogen and newborn stars, is located in a nebula in the constellation of Centaurus, around 6,500 light-years away from Earth. The intense energy these baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful that it's eating away dark clouds of dust, and they're disappearing like lumps of butter on a hot frying pan. You're continuing your journey when you see something absolutely amazing, a cloud of water floating in space. To be more precise, it's a cloud of water vapor surrounding a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself.
It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own Sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place. And Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR-124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor. But those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
You may be witness of a nova explosion visible to the naked eye any day now. At any point between these days and September, a white dwarf will go thermonuclear. Look at the northern sky over there and follow the arm of the Big Dipper as it arcs toward that star. The name of this star is Arcturus. Somewhere in the middle of that arc, there's the Northern Star constellation. Looks like a smiley face, right? So, sometime in the next 4 months, you might look to the left-hand side of the Northern Star and spot something looking like a new star. It'll shine for 5 days or so. This star system is known as Coronae Borealis, the blaze star. Most of the time, it's too dim for people to see with the naked eye, but once every 80 years or so, a powerful thermonuclear reaction makes it more than 10,000 times brighter. The last time it happened was in 1946, and now it's our turn to see it. Coronae Borealis is a binary system, which means it's actually 2 stars. One of these stars is a white dwarf, an old star that has already gone through its fusion-powered life cycle from a main sequence star to just a giant star. The outer parts of such giant stars are eventually pushed into outer space, and what's left behind is a leftover core. That's what we call a white dwarf. At its white dwarf stage, a star is usually super peaceful. You can think of this period as its stellar retirement. Nuclear fusion reactions no longer take place. which makes white dwarfs incredibly dim. At the same time though, they're still quite hot and super dense. Their mass can be compared to that of our Sun, squeezed into the volume of Earth. Strangely enough, the retirement of that white dwarf in T Coronae Borealis is far from peaceful. This is because it has a neighbor which is really prone to littering. You can see that this other star is in its red giant phase. It's actually puffed up, and its outer parts are getting pushed into space. No wonder the material coming off the red giant is falling onto the poor white dwarf. The thing is, it doesn't take much more extra material for the white dwarfs to explode. The matter coming from the red giant will keep accumulating on the surface of the other star until it forms a layer with the depth of a swimming pool. Most material from the red giant is hydrogen, and since the white dwarf is incredibly hot, eventually there will be a spark triggering a runaway nuclear reaction and causing the explosion. The explosion is classified as a nova, which means that it won't eliminate the white dwarf or the red giant like a supernova would. Just around 5% of the hydrogen layer is going to fuse into heavier elements, like helium. As for the rest, it'll get ejected into space. After that, the process will start all over again. You see, such an explosion isn't enough to disrupt the red giant, the supplier of all that oxygen. So, it will just keep doing its own thing. This is also the reason why we can't predict when this cosmic firework will happen. Predictions in astronomy can be super precise. For example, we can calculate that an eclipse will pass over a specific city at a particular time, but other predictions can be really approximate, like, well, this star is going to explode sometime between May and September, or even a bit outside that window. Astronomers have been able to estimate this period only because they know what the events leading to the previous T Coronae Borealis explosion looked like in 1946, and now these signs are repeating. At the moment, many high-precision observatories are zeroed in on T Coronae Borealis to observe the rare cosmic event. You must have heard that humans were supposed to fly to Mars within the next 10 to 20 years, but now the mission seems to be at risk. A new study has revealed the dramatic effects that such a journey can have on the human body, and because of that, the entire plan is now at risk. Samples from over 40 missions, which involve both mice and humans, have shown that the conditions in space are likely to have an even more negative influence on our bodies than we thought. Both NASA and SpaceX are planning to send crewed missions to Mars in the coming decades, but new findings might put an end to these projects. Researchers at University College London have discovered that microgravity and galactic radiation in space cause serious health risks, and they become more and more pressing the longer someone is exposed to these conditions. Surprisingly, the body part at the highest risk is the kidneys. The research has shown that after less than a month in space, some parts of the kidneys show visible signs of shrinking. So before we go all the way to Mars, we'll need to develop measures to protect the kidneys and other parts of the body. This will allow astronauts who will take part of this mission to avoid irreversible damage to their health, which in turn means that future missions to Mars haven't been completely ruled out yet. The author of the study, Dr. Keith Sue, mentioned that they already knew about the issues that astronauts had after short space missions, like kidney stones for example, but they still don't know why such problems occur or what is going to happen to astronauts on much longer space flights, such as the planned mission to Mars. If they don't manage to develop new methods to protect the kidneys, astronauts who will eventually reach the red planet might need serious kidney treatment already on their way back. Unfortunately, the effects of radiation damage on kidneys appear pretty late. By the time they become apparent, it might be too late to prevent a kidney failure. This can be catastrophic, not only for the astronauts, but also for the entire mission's chances of success. Meanwhile, an astronaut on Mars is likely to receive up to 700 more daily radiation doses than those we get on our home planet. The Earth's magnetic field and atmosphere protect people from the non-stop bombardment of cosmic rays. These energetic particles travel close to the speed of light and can easily penetrate the human body. In space, astronauts aren't protected against this radiation as effectively as on Earth, which can increase the risk of many serious health issues during long missions. Damage to the human body can extend to the brain, heart, eyes, and central nervous system. Physicists studying cosmic radiation explain that one day in space is equivalent to the amount of radiation one receives on Earth for a whole year. Moreover, most of the changes in the genes of the astronauts are likely to be the result of radiation exposure. That's what a recent NASA's twin study claims. It has shown DNA damage in astronaut Scott Kelly compared to his identical twin and fellow astronaut Mark Kelly, who remained on our planet. Another source of space radiation are the unpredictable solar particle events. They deliver high doses of radiation in short periods of time, which can lead to radiation sickness if astronauts don't take special protective measures. Even space flights orbiting close to the Earth, including the International Space Station, have highly adverse health effects. These days, research communities are focused on musculoskeletal, neurological, ocular, and cardiovascular degeneration, and these issues can appear as soon as a few weeks into a mission. At the same time, the effects of low Earth orbit flights are less clear when we talk about other organs. More research is definitely needed.
Let's see, there's Mercury, Venus, Earth, Mars, Phaeton, Jupiter. Wait, hold on. What Phaeton am I talking about? Well, let's see. It was the beginning of the 19th century, and the asteroid belt hadn't been discovered yet. In the year 1801, one man named Giuseppe Piazzi spotted the largest asteroid in the solar system, Ceres. At that time, people believed that there was a planet orbiting between Mars and Jupiter, and Ceres seemed to fit the bill. But the next year, another astronomer, Heinrich Olbers, found one more space body following a similar orbit. It was an asteroid which was later called Pallas. This discovery helped Olbers to figure out that these two space objects could be fragments of a planet. The discovery of two more asteroids, Vesta and Juno, seemed to confirm this theory. It was believed that the planet, which was named Phaeton in the 20th century, appeared in the early days of the solar system and was later destroyed, and its debris formed the asteroid belt. Olbers' idea was called the disruption theory. To astronomers at that time, it seemed obvious that the planet once collided with a large space object, which led to its demise. The most likely candidate was Nemesis, a hypothetical red or brown dwarf orbiting our Sun. Another theory claimed that Phaeton could have gone through an internal cataclysm, which could have broken the planet into pieces. There was one more idea. Phaeton could have come too close to Jupiter and got torn apart by the gas giant's immense gravity. These days, though, astronomers don't believe in the disruption theory anymore. A new idea has replaced it. It's known as the accretion theory. It claims that the asteroid belt is all that is left of the protoplanetary disk. Supposedly, this disk had been originally orbiting the Sun, even before the planets formed. Unfortunately, because of Jupiter's gravitational forces, it never managed to coalesce into a planet. But what is this asteroid belt we keep talking about? This region is located between the orbits of Jupiter and Mars. Tons of asteroids and even minor planets are found there. Some of them can sometimes migrate or even get thrown out of the asteroid belt to the outer solar system. The four largest asteroids in that area are Ceres, Vesta, Pallas, and Hygeia. They make up half the mass of the entire belt. As for the rest of the mass, countless smaller bodies make up for it. In loads of sci-fi movies about space, the main character gets into an asteroid belt and has to try hard to get away from countless rocks threatening to smash their spacecraft. Well, it has nothing to do with the real thing. Even though there are thousands of asteroids in this region, they're so widely spaced that the chance of collision is next to nothing. Hey, but it's a movie, right? Anyway, when the asteroid belt was forming, some objects started to come together and form what we know as protoplanets. But the gravitational pull that was caused by the formation of Jupiter made such collisions too rough, and instead of forming large space bodies like planets, asteroids shuddered. Astronomers think that as a result of such collisions, more than 99.99% of the original mass of the asteroid belt was lost in the first 100 million years of the history of the solar system. Only the largest asteroids have enough gravity to get a spherical shape. Small ones are just often piles of rubble, loosely held together by gravity. And the tiniest objects in the asteroid belt resemble dust, so small they are. And all these objects, giant and tiny, orbit the Sun. There are several types of asteroids, depending on their composition and albedo, which is the proportion of light or radiation reflected by a surface. The main types are carbon asteroids, which have a very dark surface, silicon ones, you can also call them stone asteroids, and metal ones. The first two types account for around 75% and 17% of asteroids that we know about. For the first time, the asteroid belt was crossed by a spacecraft in 1972. It was the Pioneer 10 space probe. The spaceship managed to refute the theory that the belt was filled with dust that could easily damage all gadgets on board. It didn't happen. And since that time, 8 more probes have traveled through the asteroid belt. And now, I'm going to tell you some cool facts about the solar system itself. Try to count how many of these facts you've known before and write your answer down in the comments below. The solar system is a staggering 4.5 billion years old. Scientists came to this conclusion after studying meteorites, the oldest material they managed to find. But our solar system isn't the only one in the Milky Way galaxy. The galaxy we live in houses about 100 billion star systems. And if it's just our galaxy alone, what can we say about the whole universe? Now, our Sun is also insanely massive. Here's the proof. 99.86% of all the mass of the solar system is the mass of the Sun, in particular hydrogen and helium that it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Oh, by the way, contrary to popular misconception, outer space isn't a perfect vacuum. It contains not only stars and planets, but also clouds of interstellar dust, space plasma, and cosmic rays. Those are atom fragments dashing from the outskirts of the solar system. Now, one phenomenon astronauts should worry about while exploring space is cold welding. If 2 pieces of the same kind of metal touch in space, they bond and get permanently stuck together, kind of like galaxy glue. It doesn't happen on Earth since water and air keep pieces separate. You can see solar eclipses even though the Moon is 400 times smaller than the Sun. It's also 400 times closer to Earth, so it's perfectly capable of obscuring the star. But in 600 million years, the Moon won't be able to block the Sun completely because of the satellite's changing orbit. Behind the orbit of Neptune, there is the mysterious Kuiper Belt, filled with massy icy objects. The most curious thing about this space formation, though, is that the scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. The ocean on Jupiter is larger than any body of water on other planets of the solar system. But it's not the ocean you think about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is around 25,000 miles, which is actually almost the same as the circumference of Earth. Now, people got to know about beautiful Saturn's rings in the 1600s, but now we know that Saturn isn't the only ringed planet. All the giant gas planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky material and have no rings. At the same time, Saturn's moon Rhea might have a ring system consisting of 3 narrow bands. If astronomers manage to confirm it, it'll be the first time for people to discover rings around a moon. Oh, and Mars might get a set of rings of its own in the next 70 million years. The red planet's largest moon, called Phobos, is orbiting closer and closer to the planet. One day it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. And another cool fact about Mars. You've probably heard of methane gas, a byproduct of such natural processes as volcanic activity and cow emissions. Anyways, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be life on Mars? Can there be cows on Mars?